Hello. Good morning. We're going to Mars. Hi, it's me, Tim Dodd, the Everyday Astronaut. It is, of course, the summer of Mars. And I'm so excited. This is the third launch this year. Within what are we at? We're like third launch within just a couple days, it feels like, within basically a week and a half of each other. This is a big one. This is a really, really big one. This is NASA sending off Perseverance to Mars. Now, this is the follow-up to the Curiosity rover. You guys all know the Curiosity rover, right? I mean, Curiosity rover is absolutely incredible. Absolutely incredible, right? It's the SUV-sized rover that has done. It's been sitting on Mars for about 8 years now, just doing really, really cool science. Perseverance is the follow-up. It's a huge upgrade in so many ways. It has a drone with it. It brought its own drone. It's taking its own drone to Mars. I mean, come on. It's like a dual prop little mini helicopter thing that can fly. It can only fly for 3 minutes because the atmosphere on Mars is really thin. But it has a ton of new science instruments. And for me, I think I'm most excited because it's going to be producing oxygen on the surface of Mars for the first time using a little experiment called MOXIE. And it's also has awesome cameras. And to me, that's a really, really, really big deal. So here's what we're going to do. We're going to do a little thing. We're going to go to a website called everydayastronaut.com. And then we're going to click on a thing called pre-launch previews. And we've got this entire rundown here for you guys. So this is the Mars 2020 mission. Again, it's summer of Mars. We're inside that transit window right now. So everyone that's going to Mars is going to Mars. We've seen JAXA launch a payload for the UAE, the United Arab Emirates. That was the Al Amal Hope mission. Then we saw China launch their mission as well. Tianwen-1. Sure, good enough. And now it's NASA's turn. We were hoping to see, ESA send theirs this year, but it got kind of all scrubbed because of the pandemic. So it's we're not going to see that one this year. But this is still really exciting. This is the third one and last one of the year going off to Mars. And like I said, this is a big one. So the time, hopefully you guys see it up on screen. We have a countdown clock for you guys there. We're going to be bringing you guys
rocket science, a term we all use to describe something incredibly difficult. And rightfully so. I mean, just look at a rocket engine. Stare at it too long, and your brain might melt. Trying to grasp all the concepts involved in rocket science can be incredibly intimidating, and yet rockets were designed and virtually perfected in an era when computers were the size of a room and most calculations were done with paper, pencil, and a slide rule.
Touchdown confirmed.
The sheer brilliance of the people who have figured all this stuff out blows my mind. I, on the other hand, am a prolific college dropout. My name's Tim Dodd, but I became known as the Everyday Astronaut when I randomly bought a Russian spacesuit as a joke, took pictures of myself with it in just about every imaginable situation all around the world in a viral photo series. And in the making of that series, I fell head over heels in love with spaceflight.
I mean, guys, would it be an Everyday Astronaut live stream if we weren't tweaking things last second and trying all these new things every time? This one, the reason we're doing it this way is so we can do this live telemetry for you guys, because it always bugs me that the NASA launches and ULA launches don't really have good live telemetry. So we have to bounce this RTMP over to Andrew over in is West Virginia or one of those. North Carolina, that same thing. North, South, West Virginia, who knows? North Carolina. So sorry, we thought we had it. We thought we had it. But we're finally back. Okay. Anyway, let's get back into the pre-launch preview here, and I'm going to tell you guys all about this mission. If this happens again, we're going to bounce out and not provide live telemetry. But so far, hopefully, it's just going to be no problem now. So, okay. Go to everydayastronaut.com/pre-launch preview. You can get everything you need to know for this upcoming mission. So this is taking off today, July 30th, 2020 at 11:50 UTC. You can probably see in the time clock right above my head. That's how far away it is. We're within about 1 hour at this exact moment of the launch here. So the mission name and what it is the Mars 2020 Perseverance. So the mission name is kind of Mars 2020. The rover is Perseverance. And this is the launch of NASA's next Mars rover. So this is, like I said, this is a big deal. This is properly a flagship Mars mission, a flagship NASA mission. So that means it has the highest funding. This is like $1 billion rover going to Mars. I already have a video that goes really, really deep into all of the details. If you want to compare Perseverance to Curiosity, I've got you covered. We did a full-blown rundown on it, and it's awesome. Doing research for that video got me really excited about Perseverance. So I'm ready to go for this thing. So, all right, the launch provider for this, the company that's taking Perseverance to Mars, basically the UPS or the FedEx or DHL of this launch, is United Launch Alliance. And the customer, of course, is NASA. I probably don't need to spell out this acronym, but just in case, the National Aeronautics and Space Administration. The rocket, so the rocket that's taking it there is the Atlas 541, and 541 is the configuration of that rocket. So that means that it has a 5-meter fairing, 4 strap-on solid rocket boosters, or rocket motors, you might hear ULA refer to them. Same thing, they just different nomenclature. And a single RL-10 engine on the Centaur upper stage, which is the normal configuration. We've only seen one Atlas V ever launch with 2 RL-10s on the upper stage, and that was for Starliner missions when they start putting humans on Starliner and on top of the Atlas V. It will have 2 RL-10s on the Centaur upper stage. And then, yeah, that variant in particular is called the N22, the no fairing, 2 solid rocket boosters, and 2 RL-10 Centaur upper stages. So this was the 541. This is basically almost the biggest, baddest Atlas V, and it takes all the power of that awesome rocket to be able to send something this big to Mars. So this is taking off from Space Launch Complex 41, which is at Cape Canaveral Air Force Station, or kind of, it's still... We're in this awkward moment where I don't know whether to say Air Force Station or Space Force Station, because it's kind of both. Some of the signage has changed to Space Force Station, but technically a lot of the things are still Air Force Station, so who knows? We'll just say Air Force Station for now. But we know it's there and not at NASA's Kennedy Space Center because it's SLC 41. So that's Space Launch Complex 41. If it was just LC Launch Complex, that is a NASA property. Launch pad, like LC-39A, LC-39B. So, yeah, that way you will know. which place it's taking off. And they're right next to each other. I mean, it's all out at the Cape, basically. So Cape Canaveral Air Force Station and NASA Kennedy Space Center are separated by just a little. It's arbitrary, basically, but it still matters. The payload mass, this is just over a metric ton at 1,050 kilograms. That's about 2,315 pounds for those of you that are metrically impaired. That's pretty heavy. That's like a nice, nice light car. Back in the 90s, they used to make cars that light. This would be like a Honda Civic or something, like back in the day before, we actually had, things like hundreds of airbags and things. Now I feel like cars are very heavy. Okay, where is this satellite going? This is going to Mars orbit initially. The initial capture orbit is 150 by 270. So this is a little bit of a remnant from SpaceX because the question is, will they be attempting to recover the first stage? No, this is not a capability of ULA currently, although they will be working on smart reuse with their Vulcan rocket, which will recover the engines. Where will the first stage land? It will not land. It will crash into the Atlantic Ocean, as every rocket before the Falcon 9 basically did, besides, the space shuttle, basically. Will they be attempting to recover the fairings? No, again, this is not a capability of ULA. That is also a remnant of SpaceX launches where they are catching the fairings. So these are new fairings. This will be the fourth flight for ULA in 2020, the 139th flight for ULA all time, the fourth flight of an Atlas V in 2020, and the 85th flight of an Atlas V all time. So here is our graphic from Jeff Barrett, who has kind of the vehicle and all the stuff pulled up here, the launch complex. So one of the things to remember here, guys, the Atlas V is actually basically the same diameter, just a tiny bit bigger, 0.1 meters wider and about 4 inches wider than the Falcon 9. But they're almost the same diameter. So although it might look bigger, like I think I used to think that the Atlas V was bigger altogether, it's about the same diameter as the Falcon 9. The Falcon 9 is just extremely tall. So this is 60 meters in height, and the Falcon 9 is about 70 meters in height. So it's a big rocket, and it makes up for some of the lack of height by having the strap-on solid rocket motors as well. So, okay, so if you guys want to read more and more and more, we have the entire the entry, descent, and landing of this mission pulled up on the website for you guys. So if you want to know when exactly is it going to land on Mars, well, it takes 7 months basically. We'll get there in February, and here's the exact timing of getting into Mars. Pretty darn cool. So if you guys want to look at all this stuff, how awesome is this? We have everything here pulled up for you guys. So if you want to know more about this, you can watch my video. And if you want a resource, just check out the website here. We just have it all laid out here for you, nice and easy, so you know all of the things. And I just love I'm so proud of my website crew. They are just kicking butt. But here's some of the overview of the actual instruments that are pretty awesome. So like I said, the one that I think I'm most excited for is MOXIE, which will produce oxygen on the surface of Mars for the first time. It's not going to be a lot. It's more of a technology demonstrator. But producing oxygen on a planet that has virtually no oxygen is extremely important. It has something like, was it 14,000 times less oxygen per liter than here on Earth? So not only is Mars's atmosphere extremely thin, as my shirt will tell you, this is my new favorite shirt. It's the Future Martian Society shirt. And it shows you the atmospheric composition and the gravity on Mars here on your sleeve. There's not much oxygen on Mars to begin with in general, and then it's only 1%. The atmosphere is only about 1% as thick as Earth. So there's very, 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 very little oxygen on Mars. So being able to make it out of the atmosphere is extremely important. But the other thing that I think I'm also really, really excited for is the upgraded cameras. So there's a super cam, mast cam. There's also Watson, a camera out on the arm. The cameras are upgraded. There's altogether 21 cameras heading to Mars. Some of them are going to be on the lander because we're actually going to get really high quality footage of the landing, including a microphone. Same with on the rover itself. We'll have a microphone too. So it's not going to be the first time we've heard Mars, because InSight lander that launched about 2 years ago also had that also had a microphone on it. So it's not like
we explore Mars. The mysteries of the red planet.
Hold on, we actually have a feed here from NASA. Let me see what it actually is, though, because NASA's like, what are they? Hey, no, show me the thing. Where's that coming from? Okay, well, I'll have to figure that out in a second here. But anyway, let's pull up the camera. Like I said, this is NASA's feed. Hopefully this didn't bork it here for you, Andrew. I'm really trying to figure this. Hey, Andrew, can you go full screen here for me real quick? And I'm going to check out where that audio is coming from. Okay. So let me figure this out. I don't know why I just have random audio right now of like a Mars mission. I must have it pulled up somewhere, and I can't find it. Yeah, somewhere in my 18 million tabs is, where is this? It's gonna drive me insane. Help! I need an adult. Someone save me. Or is it this? Oh my gosh, it's the NASA, it's the media feed. It was the media feed. The one that we have pulled up just has random audio going over it. Come on, NASA. Okay, so we do finally have a pad camera here for you guys that I'll show you guys. Sorry about all of the jim jam there. I didn't expect the clean feed that we're getting sent from NASA to have a bunch of random audio going on, scaring me, scaring all the kids. Yeah, and it has been upgraded beyond 2 frames a second. So at least they hit some kind of button, and it did a good thing, and it also did a bad thing for me, and I'm very excited though. So that is the Atlas V rocket. Now that we have visualization of it, a live feed, I think it is time that we do something extremely important. We're going to do the orientation check. Now, this is something that only trained professionals can do. I've done years of nothing to deserve this honor besides mental focus. But I'm going to go ahead and call up right now. The pointy end is up. The flaming end is down. I think we're going to Mars, ladies and gentlemen. I think we're going to Mars. So one before I pop into our chat here quick and hear from you guys, I did want to mention that we do have these shirts are available right now. The one that I'm wearing, the Future Martian Society, which is my new favorite shirt, I think. And this has Arcadia Planatia on it, which is the Prime A candidate landing site for Starship eventually someday, with the exact landing coordinates. It also has, like I said, on the sleeve has the atmospheric composition. If you guys want, this is 10% off for the next 24 hours, basically from right now. If you use coupon code LaunchDay at checkout for that shirt. Also, we have brand new full flow stage combustion cycle hoodies 2.0 finally, much improved. They now have totally different custom sewn tags, custom hoodies, thingies, stringies. On the sleeve, it shows you the pressure and the specific impulse and the thrust output of the Raptor engine. Yeah, it's new and improved. I can't wait. I know it's in the middle of summer right now, but you got to think a season ahead, people. You got to think a season ahead. And we also have brand new removable for-flight keychains, as well as masks as well for all your... Actually, there's face hole cover, not a mask. So yeah, for all of your face hole covering needs, we've got you covered. Head on over to shop.everydayastronaut.com if you guys want to help support what I do and get some awesome merchandise for yourself. This, of course, just helps me continue to do what I do. These are all very premium materials. We hand make them here in the U.S., hand screen printed. These are not print on demand. These are run items. So, yeah, it's a lot higher quality product for you that way. All right, let's pull up the rocket because we are... Looks like we have LOX loading starting. So this is pretty much the end of the checklist, or the start of the checklist, actually. So, okay, like I said, we do have the pointy end up, flamey end down, and now the LOX loading has begun officially, which started happening around T-minus 1 hour and 3 minutes. Hey, there we go, Andrew. We do have their holding clock in that shot right now. They're out of hold at 17:30. Hey, I thought this was a clean feed. No wonder I was so confused. Oh, look, they even have to have shields up because of the pandemic. But that looks like it's a gorgeous morning out there at Cape Canaveral. It's so weird to see a huge mission like this, a Mars mission with no one out there. That just hurts me because I'm so used to seeing the press site just absolutely crammed. Now, do notice right now the rocket looks like it's half white and half gold. Normally that whole first stage, all the way up to basically where all the condensation is pouring out right now, normally the whole thing is gold. But what you're seeing is the liquid oxygen. That's the liquid, or that's the liquid hydrogen tank. That's the liquid oxygen. Yeah, sorry, that's liquid oxygen below it's the RP1 on the first stage. And what you're seeing is liquid oxygen is so cold. It's like minus 180 degrees Celsius ish. and the ambient air around it has humidity. When it touches that really cold tank, it actually ends up with a layer of frost. So that's a sheer layer of ice up and down the rocket, making it look white now. And even though a few hours ago it was like entirely gold on that first stage. But yeah, pretty exciting stuff. Let's get to some of your guys' questions here. And again, reminder, the smoke that you're seeing, that's not smoke. It's really, it's from that liquid oxygen boiling off. So liquid oxygen, when it turns into a gas, it's still really cold. It's still around minus 180 degrees Celsius, but it expands 1,000 times. So they need to let it vent so it doesn't pop the tanks and rupture the tanks. And so it's totally normal for there to be what looks like smoke, but it's really just, it's basically little ice clouds, little clouds of condensation. It's the humidity in the air, coming in contact with that really, really, really cold, just barely not liquid oxygen, just really, really cold oxygen. So, all right, we've got some stuff here. We've got Kinetic Cowboy saying, thank you so much, Kinetic Cowboy. We've got a fresh hot dog. Wait, fresh hot dog. Fresh hot coffee and the smell of an RD 180 rocket exhaust. Good morning, Tim. Thank you so much, Kinetic Cowboy. You're exactly right. Ooh, we've got some fancy stuff going on from NASA. Look at this. Wow. Okay. I've never seen this before. All right. We also have Charlie says, thanks for bringing space down to Earth for everyday people. Thank you so much. We have a new membership from Jurgen. Thank you, Jurgen. This is not sanctioned by me, but thank you, DB Crypto. I mean, I don't know if it's 6 a.m. here, so we're just sticking with coffee. We're not doing any kind of Irish coffee or anything. Brad Gallant says, I really admire your drive and motivation for learning what you do. I'm a computer science major, and I hope to work for SpaceX someday. Brad, do it, man. Like, seriously, the coolest thing about all this stuff to me is that you can be sitting at home right now watching humans come together and do something, quite frankly, absolutely bonkers. And it's just so weird to me that, people's lives change because they get inspired by something. And to me, there's nothing more inspiring than going out and exploring space and learning more and more about our place amongst the stars. So if you work your butt off, why not? Why can't you work at SpaceX? Why can't you work for NASA? Why can't you work for ULA, Rocket Lab, any of the, Blue Origin, any of the people out there helping us get deeper and deeper into space? It's just an exciting time where the inspiration is never ending. So let's see here. This is okay. I'm gonna. Should I pull up the? I can try pulling up the other one here. If you want to go full screen for me. Okay. So we got NASA TV. I'm on the media one here. I'm gonna give it a little refresh though. See if we can get. Their clock is probably in that hold. Hang on here. Are you seeing Raquel currently on your screen or launch time 41 minutes, Andrew? 41, 37, 36, 35. Okay, cool. Sounds good. We're just making sure that we're synced up because we do have a little bit of doot between Andrew and I across the coast. So we're just making sure that we're all lined up here. So, okay, this is from Kumquat Lord. Won't be able to make it to the launch because of work, so have some money for a coffee. Also, your Team Space shirt, maybe a sports jersey. Literally, yes, that's exactly what we're currently working on. Is we're thinking about making a sports jersey, and I will tell you what kind of jersey in the near future. I don't want to spoil you, and do anything. Oh, this is cool. This is the United States' journey to Mars. You can see all the different things that have been sent off to Mars. It's pretty, honestly, it's pretty nuts. If you look at the history, if you look on Wikipedia and look at missions to Mars, Mars is actually really hard. It's still just barely above 50% of what has been sent to Mars has been landed on Mars. And with the United States being by far the leader, there's been very few other missions that have successfully touched down on the surface of Mars. It's still really, really hard to do. Really hard to do. David Willis says, yo, let's get to Mars. Let's go to Mars again. Yeah. For, as we saw there, it's the U.S. has sent, 8 landers now or something? I mean, the U.S. has sent a lot, or successfully landed a lot. Look at how big Yeah, the Curiosity and Perseverance rover are. Again, Curiosity is basically the brother here to Perseverance. They're going to be very, very, very similar. There we go. That's a funny looking picture. They're actually the same chassis, so it's virtually the same thing. They chose a different view there, though, for Curiosity. Even though, yeah. Okay, so I don't know. It might be. Okay, this is from I am Mr. Mech. Thanks for the videos. Love your work. Off topic question. What would be the best way to thicken the atmosphere of Mars for unpressurized suits? So I'm not a planetary scientist. So I don't know, like, of course, there's the old saying of nuke Mars, and that's kind of Elon Musk's idea of how to do it, because you can basically try to do like hopefully not a runaway, but you can try to do greenhouse gas effect by nuking the poles of Mars and trying to get some of the, as far as I know, again, not a planetary scientist. I'm not, I don't know why you guys are listening to me, period, but I know almost nothing about planetary science. But the idea is basically, you nuke the poles where there is some water ice trapped on the poles. You can release some of that into the atmosphere. And, if you do it right, you can actually start to develop an atmosphere. And because it's so, that's about all I know is you can nuke Mars and eventually make an atmosphere-ish. That's about it. Ooh, this is cool. Look at that. That is basically what they think Mars looked like at one point before its atmosphere and everything got stripped away. Pretty nuts, actually, to think about. And this is Jezero Crater. That's where this vehicle's heading, which they believe was absolutely filled to the brim, basically with water. So it seems like a really, really good place to explore. So this is an ambitious mission, because this is the first time we're really going to be properly looking for signs of life, and not just like potential signs of life. It's kind of like, no, we're actually going to really, really, really try this time. I know that sounds weird, but yeah, I am just excited for this mission. All right, Adam Bailey says, I'm sitting between Decatur, ULA, and Huntsville. So pumped for today's launch. Hey, you're right there in Space City. That's a good place to be, really. I feel like, yeah. But by the way, speaking of Huntsville, I just need to give a shout out real quick to Space Camp. I don't know if you guys are familiar with Space Camp. It's like the Space Camp, like NASA sanctioned Space Camp there in Huntsville. They are in a really weird spot because they're like it really sucks. They don't get any federal funding. They don't get any state or city funding, really. So they have been hit really, really, really hard by the pandemic. If you guys have even $1 to spare, please go to savespacecamp.com, because without our support, they will be completely gone and forced to close by October already, which would end decades of awesome inspiration and a way for kids to go out there and learn. And it's a really big, it seems like they're really big into like team building and simulating, space experiments and stuff. So yeah, if you guys have just a second of your time and $1, savespacecamp.com. It makes a big difference. There's a lot of international grants to help students from all over the world come to Space Camp and come together. And I've always thought it was a really important thing, something that I wish I could have done when I was young. So yeah, just thought I should throw that out there since I saw Huntsville. Let's do it, guys. New membership from Kim. Thank you so much. This is from the Novlin. Saludos, Marcianos. I think that means good morning. Martian? Maybe? Thank you very much. This is from Dag214. Hi, Tim. Your passion, drive, and commitment to being awesome are what makes your YouTube channel so cool. I hope when I grow up, I can be as cool as you. I'm 57, by the way. Keep it up. Thank you so much, Dag. Oh, and that is extremely generous of you, too. Man, thank you so much. I did. Well, thanks for the laugh, and thanks for the extreme generosity. Holy cow. Thank you, Dag. Hey, I feel like I'm still growing up too. All right. This is from Ignacio Montenegro. Says, I learned English watching your videos. That's awesome. Like I said, we do always try to get, oh, look, it's Tori Bruno, the CEO of ULA. Tori is awesome. I love like Tori Bruno, Peter Beck, Elon Musk. These guys know their rockets inside and out. Like, they know the nuts and the bolts Tori, you have to watch the interview with him and Destin from Smarter Every Day, showing, again, speaking of Huntsville, basically, Decatur, he got a tour of the ULA factory, and Tori's just casually walking around, knows literally every single little bit about everything. He's just, and because he's a rocket scientist, he's actually properly a rocket scientist, and importantly, he worked on a rocket that I'm very fond of, that I don't want to say that I have a love-hate relationship with it, but I definitely, it's definitely one of the wackiest things that would have ever flown was the Venture Star. They made an X-33 prototype, almost got it done. It was like 95% complete, would have been a single stage to orbit. Well, the X-33 was a subscale version, but it was going to eventually be a single stage to orbit, basically giant space shuttle thing that had a linear aerospike on the bottom. One of the coolest rocket concepts of all time. Got canceled in the, late 90s or early 2000s. Really good video. Again, Tori Bruno is awesome. I can't wait to sit face-to-face with him someday when that's possible. We've been trying to link up for like a year now almost, and it just has not happened. And I can't wait to ask him I want to ask him about that, because that's a history that I don't want to get lost. And I know he knows everything about it, but I also want to talk to him about their next rocket, the Vulcan, which will be incredible. The Vulcan's going to be a beast, honestly. So, all right. This is from Christopher Johnson. For Nessie, when you see her. For Nessie, when you see her. I don't quite know what that means, but thank you. Am I missing something? Does Nessie mean something? It's funny because I call I have a different mic that I use for shooting videos. It's a Sennheiser, and I call it Senny. So I was thinking, like, wait, I have a little bit dyslexic, so I read that first as Senny when you see her. I'm like, how do you know about my mic's nickname? But this is from Milhan says, oh gosh, I've realized I forgot to send you my t-shirt idea. My bad. Sorry. Hey, it's all right. Stuff happens. No big deal. I look forward to seeing it. Mars slips now from the Novelin again. Hello and thank you. I don't quite know what that means, but it does slip now slightly in front of us at first, and then our orbit will slip underneath it, basically. Sure. Thank you again, though. Ground-based space. Hey, Tim, excited to join you for the launch. I just received some cool space merch from Scottish space firm Skyrora. That's awesome. I need to learn more about Skyrora. There's a lot of stuff happening right now. There's so many new launchers coming out, and it's really exciting to me. So that is awesome. Hey, do we have any? Nope, we're still. That's right. They do the planned hold. So one of the things that's really hard to track and hard to figure out here with these launches with the ULA, any ULA launch, is they do these planned holds. So if you're watching a ULA launch, a United Launch Alliance launch, so right now that'd only be the only two rockets you're going to see would either be the Atlas V or the Delta IV Heavy. The single stick Delta IV has been retired. So the big 3-core Delta IV Heavy, if you see that launch, they do these things where they do planned holds and the countdown clock will stop at T-minus 4 minutes. And then they'll like go into the terminal count. So basically that's the portion of the rocket that is automated, just those last 4 minutes. The rest of the countdown sequence is not as automated. It's more like kind of checking it out, and then they do like another go, no-go poll. So it's a little different than what we're used to seeing with SpaceX, where it's basically like they make sure everything is good to go, and then they start the automated countdown, and it's going all the way to T-minus 0, assuming it doesn't get interrupted. So yeah. This is awesome. Holy cow. First says, hi, Tim, it's me again. And the Chinese subtitle for your Perseverance is already finished. Dude, okay, I will get in there and check that today. That's awesome. Thank you so much for doing Chinese subtitles. That is amazing. Okay, I will get that published. Thank you. For those of you that do any of the translations, I need to get better. I probably need to get like a team member to start just going through those, once a week or something and making sure that they're good to go. Because, yeah, they can get a little overwhelming. So, yeah, that is awesome. So thank you so much. D3AD Chris, wait for it. Words with a clock is the A. Words with a clock. I'm sorry. I don't have any idea what that is. Again, yes. Maybe it's just too early and everything's going over my head this morning. Arcadia Minecraft. Thanks for getting up early with all of us to watch this launch together. Here's something to help you upgrade your website to handle more traffic. Yeah, sometimes our website gets absolutely borked. I apologize about that. We're trying, and we're actually working in the back end as we speak of like doing a big overhaul of the website. So stay tuned. Hopefully by the end of the year, we have something new, fresh, and totally updated for you guys. We're also working on updates to the store as well, including by the holiday season, we're working on having a European distribution, which is actually it's really hard to handle that stuff logistically. So that's one of those things. I should remind you guys one last time here that is not smoke. That's totally normal. It's really, really, really cold air. That's actually the liquid oxygen boiling off. When liquid oxygen changes from a liquid to a gas, like what we're used to, we breathe it in as a gas. No one's out there sipping liquid oxygen. You would freeze instantly. It's still around minus 180 degrees Celsius. So it's really, 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 really cold. And so when it comes into contact with the air, just like when you see dry ice on the ground or when you open up a freezer or something, you see that condensation that kind of can happen where little ice particles will form in the humidity in the air. And that's exactly what we're seeing. So as it boils off from liquid into a gas, it expands 1,000 times. And so it doesn't rupture the tanks. They have valves that make sure that it's letting go. But you can still see how cold the rocket is. Look over between the booster and ULA. You can see just it looks like steam pouring off. It's really more like little ice, little particle ice clouds. We also are going to work on a shot here for my friends at Cosmic Perspective. They're working on their feed this morning as well. They are currently at the causeway. We're going to have our own shot of the pad if we want to stay on it, which we'll probably do here. And then we're gonna hopefully go into the countdown here, and we're gonna also have the go no go poll for you guys up on screen as well. So, Andrew, are we gonna be able to actually hear the go no go poll? Unless I can probably turn it up on my end. Yeah. Okay. Well, it's right now them talking. There is talking right now over the clean feed. So once we get into the go no go poll, I'll increase the volume, and we'll do that. So, okay. So Sagar says Mars is known to have unbearable radiation for humans. Does the rover have any experiments to solve it? If not, how will NASA solve the problem? Will MOXIE be used instead of oxygen cylinders for respiration? Good question, Sagar. Sagar. Sorry if I'm totally mispronouncing that. So the radiation environment on Mars is definitely not pleasant. You can't really survive on Mars without shielding. And the big reason is because you could easily survive on Mars, the radiation environment, for a week or two or a month. The problem is in order to go to Mars and back, you're going to be on the surface of Mars for like a year and a half, right? You're going to be there for a long time, exposed to high doses of radiation. It's actually not that high. Like literally, if you were just sitting inside of a capsule, like a normal spacecraft on the surface of Mars, I don't think the actual potential, the radiation and the potential risk for cancer, I don't think it's any higher than smoking a pack of cigarettes a day. Like it's literally within the same realm of that. And there's still plenty of people that do that. So it's not like it's like a death, it's not a one-way ticket. Like you're just going to get fried and zapped by the sun and you're going to die. It's not that bad. It is bad though. So they'll want to take that into consideration, when there's going to be habitats on the surface of Mars. It's definitely going to want to have some kind of radiation shielding. But most likely, one of the most common trains of thought is not to build something, but is actually to go into like lava tubes or tunnels and dig down into the surface of Mars and only have one, outer interaction between the environment, basically like one kind of hatch on the outside of that. And that way you're protected by a good amount of regolith. So it's good radiation shielding. So yeah, that's kind of the thought. Same with the moon. People think we should use the lava tubes on the moon for habitations for long-term stuff, because it just does not make that much sense to be up on the surface and exposed to that much radiation. So good question. But as far as solving it, yeah, and as far as experiments on this, that's actually something that Curiosity did. Curiosity measured radiation environment really, really accurately and helped us like kind of map the conditions of the radiation on Mars. So we have a good sense of that, and we've had a good sense of that for the past basically 8 years now. So yeah, so good question there. Oliver says, I would love to work for SpaceX or Blue Origin, but unfortunately, ITAR is in the way. Thankfully, I can still watch and enjoy the progress. This is true. There are some restrictions. ITAR is like the International Treaty of Arms, and rockets are still kind of considered a class of weapons because they could be a delivery system for weapons. So in order to work on rockets in the United States, there's really, really strict restrictions on who can get in. I think at SpaceX, like you can get green cards. There are workarounds. And you can't get, I think you have to have a green card. I don't really know at all how that stuff works. So, but basically, it can happen. It just is maybe a bit difficult. So, but yeah, hopefully, maybe you can figure out a workaround someday. And there's also a lot of international companies. Like, for instance, you can work at Rocket Lab in New Zealand because some of the stuff doesn't deal with ITAR. I think. Don't mark my words for sure on that. Someone let me know if that's for sure the case. But I think it's a little easier to work at, say, Rocket Lab, who is an awesome company. So yeah, you can maybe look into them if you're considering something like that. So yeah, good question, good call. All right, we have a new member here, Richard. Thank you so much. From South Australia, here we have Undercover 227. Hey, from South Australia, was able to get a photo of Neowise tonight and a launch. How awesome! Yeah, that's a good day. Going out and seeing the comet Neowise, and getting a launch to Mars. I mean, this is a big day. I'm really excited. This is going to be a big week for me trying to do live streams because here's what I've got coming up here. So obviously, right now we've got the Perseverance mission to Mars. Huge deal. Really, really big launch. We're also seeing Starship get ready to static fire and hop their serial number 5 Starship prototype out of Boca Chica. I'll be streaming that whenever that happens, hopefully. We also just shot a video talking about how you get back from space, how you get down from orbit, specifically all of the details about the Crew Dragon capsule and how it returns to space. And we go into all of the orbital parameters, all of the reasons that you get into, basically all of the things that are the things. So we'll teach you all about that. It's going to be a long one, and that hopefully will come out on Saturday already. We're trying to push it through. Andrew and I are going to be doing some no sleep seasons, I guess. So wish us luck. It's going to be a deep dive. It's about 30 minutes probably. But you'll really, really, really understand orbital mechanics and how to get back from space. Because going back from space is different than like coming back from orbit. If you're suborbital, that's totally different. Coming back down from orbit is a whole like nutty thing, honestly. So I've got a lot of good content for you guys coming up. So stay tuned. Ben Hockley, why don't they just perfect? I love it. I should just mention this now. If you guys, we have a segment on a podcast I do every week called Why Don't They Just? And it's questions like, why don't they just use a helicopter to grab a rocket before it hits the water? Why don't they just use a trampoline or why don't they just use a slingshot to get a rocket going? Or why don't they just use maglev? Why don't they use a tube or whatever? Like all of those types of questions. We answer a question like that every week on Our Ludicrous Futures, a podcast I do. So if you want to hear more about spaceflight, more about the week's news in spaceflight, just hear more from me in general, olfpod.com, olfpod.com. That's Our Ludicrous Future. You can find it here on YouTube or just whatever, media player you have. And so this is a why don't they just mass produce a series of a dozen rovers to get costs down and send 1 or 2 every interval. Well, see, there are some commonalities between, like, there's buses of satellites. So there's certain satellites that do have a common bus. They have common subcomponents, and they're just kind of cranked out, and that does help bring the cost down. Rovers, there have been 2 now. This is literally some of the parts on Perseverance were like kind of backup parts for Curiosity. So it is a little bit of that where they built 2 identical. Same with Insight, and was it Phoenix Lander? That's the same. So it's a thing that they do already a little bit, but not necessarily mass produced because technology changes so quickly. I know it doesn't necessarily always look like it, but also these are so bespoke things. It costs a lot of money to still do it in the first place. So it's not like you'd really have a hard time telling Congress, hey, okay, here's the deal. Right now, these rovers are $1 billion. Okay, so we can afford to get, one of them every decade, basically, right? And then trying to be like, okay, now hear me out. We can bring that cost down in half. All we have to do is order 30 of them. So So now we're looking at, I don't know, whatever that is, like 15 billion or whatever, or do the math. It'd still be a hard sell. Like, yeah, we're going to send 15 of these things to, I don't know. So I don't even know what numbers I use there. I totally probably messed something up there, but it's still something that's like, they're so bespoke. Everyone has different mission parameters and different things that they're trying to study. That it doesn't always just make sense to use an off-the-shelf component, or there's too little commonalities between missions, between destinations even, to really, really make something like that that useful. Although I think we will see something more like that. You know what I think? Mark my words. I think it's going to be smart pretty soon to start just sending like Boston Robotic, like the Spot. Is that what it's called? That little off-the-shelf just robot that you can even put an attachment arm? Because that's like $100,000, I think. I think it's only like 75 grand, only 75 grand. And you can even put, like I said, you can have like arms on it. Send a dozen of those down to Mars and have them all programmed to do slightly different things and interact with like a little house thing that they can, put experiments into and all that kind of stuff. To me, that makes sense because it's like, who exactly, like, who knows what we could do with that? And it could be really cheap and a really easy way to do it. I've got a little treat here for you guys. I'm going to pull up a clean feed here from my friends at Cosmic Perspective. My good friends, they're down there at the Cape. We're going to see what it looks like. They're about 3.5, 4 miles. So that's about 6 or 7 kilometers away. This is their shot through a telescope. Look at that. So that's a shot through a telescope. That's how close they are to this rocket. That is so cool. So this is Mary Liz Bender and Ryan Shalinsky. They work so hard. They're at basically every launch. You've seen me on Twitter and everything, and probably some of the videos that I did with them before the pandemic. They film all this stuff in super, super slow motion. Gorgeous footage. Genuinely, I think some of the best footage of rockets I've ever seen in my life. These two work their butts off and do really cool things. So just throw them some love there on Twitter, Cosmic Perspective, and find them here on YouTube as well. And I can't wait to see that they track. We got it so that we're tracking the rocket with telescopes. It's pretty cool stuff. So send them a little bit of love and tell them I said hi. And we'll probably pop back to that camera if this thing's bouncing all around too. But we're gonna stick on the NASA feed for the actual launch. Because they'll be going into a vertical orientation with their camera. So their camera, they turn it vertical because by the time the rocket will do a gravity turn. So it starts going up. And the only reason you go up with a rocket at all is to get out of Earth's atmosphere. So there's really two main factors that rockets deal with. And that's gravity and the air, the atmosphere. And both of them at first are really, really working against you to try to get off the planet. And really one of the bigger forces at the beginning is I guess gravity is basically constant, but the aerodynamic forces are really high down at sea level. So that's why rockets go up. If there wasn't an atmosphere like on Mars, you could basically go straight sideways and get into orbit. As long as you're at a high enough point to not run smack into a mountain, you could get into orbit at say right now on Earth, if you're on top of Mount Everest and you launch straight sideways, you could be in orbit and buzz the top of Mount Everest every time you're orbiting if there wasn't an atmosphere to contend with. But of course, even at Mount Everest, where the atmosphere is still pretty thin, like humans have to wear oxygen masks, it's still thick enough that you would deorbit instantly, basically, and burn up because the atmosphere is still that thick. So rockets just go up to get out of the atmosphere, and then they start to pitch over because in order to go to space, you can go straight up. You can go 100 kilometers, 62 miles up. You'll hit the Kármán line, but if you just go straight up and hit that point, you're just going to fall straight back down. So in order to stay in space and to get into orbit, you have to go sideways really, really, really fast. You have to end up going about 28,000 kilometers an hour, 17,500 miles an hour or so. You have to just be absolutely screaming 10 times faster than a bullet sideways. And so that's all rockets is literally just, it's a continual, like, starting off pretty low, around 1.2 to 1.5 Gs of acceleration. But as they get lighter and lighter and lighter, they just start screaming. They get up to, they'll pull 3-4 Gs the rest of the way, all the way to orbit for 8 some minutes, just pulling 3 Gs. You eventually get up to orbital velocity. So they go up to get out of the atmosphere, and pretty soon they pitch over and will, end up getting up to orbital velocity. So anyway, long story short, that's why cosmic... Geez, that was a long science rant there. but in order, that's basically why cosmic perspective, that's why they shoot vertically, because not only do you get a full frame of the rocket in there, but also it ends up pitching over at some point and you still get a nice full shot as well. But that way you can frame the entire vehicle on ascent when it's actually, wait, I kind of said that wrong, because now that I think about it, it pitches over in their frame. So horizontal would be the best, but yeah, they go vertical just purely so they can get the full rocket in. So we're not going to have that pulled up at that point, but still, anyway, I still love them, and their shots are absolutely incredible. Sorry, that was a long rant there. This is from Captain Obvious. There's a floating mesh gel proposal to terraforming. You should check it out. Oh yeah, I kind of know a little bit what you're talking about. I've heard about it a little bit, but I should definitely check that out. Thank you, Captain Obvious, and what a great name. This is from N. Ziegel. Hey Tim, it's nice to be joining you from New Zealand. But this is probably New Zealand Eagle 1. A bit off topic, but have you seen the suborbital space plane that Dawn Aerospace is starting to test to be launched from New Zealand in the future? I actually did just see that literally this week. I think I saw it on Twitter or something. That's pretty exciting. It seems like New Zealand's kind of got the rocket bug now. Rocket Lab has injected them with a good amount of rocket goodness. That is pretty darn awesome. So, that's really, really, really cool. There's a lot of new aerospace companies popping up right now, and I need to do a summary someday of, like, we almost should do like a yearly summary. Here's all of the people trying to get to space that haven't yet. That would actually be a cool video, and we'd have to do it every year because it changes constantly. So we could do like who's dropped out of the test and who's new to come. There's some really cool ones. Like Vector we lost last year, I believe. But Relativity's coming online. There's just so many. But it's for good reason. It's fun to try to come to this problem in a little different way. Like 0 to infinity using balloons and basically a bunch of donuts and a muffin to get into space. Like, there's some cool ideas out there. Hang Time Central. Remember, everyone, play Life on Mars by David Bowie 45 seconds before launch. The big hit of the song happens at T0, especially since it's a Mars mission. That's awesome. That's a good idea, Hang Time. I wish I could do that, but of course we'd get smacked with a big fat copyright strike, so we're not going to be doing that. But that sounds like a really cool idea, though. Thank you for that, Hang Time. This is from Beetlejuice X. Remember watching Curiosity rover landing on Xbox 360 back in the day? Do I have a rover memory, launch or landing? SpaceX will analyze this Mars entries, by the way. Ooh, that's cool that SpaceX will be analyzing the Mars entry. That makes sense. That's really, really cool. So as far as, are we actually getting into the go, no-go poll yet? I don't think we are quite yet. But we should be just about any minute. Yeah, I think we're really, really, really close to that. Okay, so as far as, what? I barely remember Curiosity landing, and actually, you know what? Now that I think about it, I also think I watched it on an Xbox 360. Now, I actually think that's how I watched it too, because I don't think I had any other media device back then besides the computer. Oh, here we go. Is this the? We're getting ready for go no go poll. I'm gonna. Okay, here we go. We're gonna listen to the go no go poll. This will tell us if we're launching this morning. And I'll get back to your memory or your thought there, Beetlejuice. But we're gonna listen in here. This is a big deal. It's not doing anything right now, so you won't be hearing it. Sorry, I'm waiting to hear. I'm talking. You're hearing me half talk to my producer, who's in my ear here. And everyone say hi to Andrew, and also say hi to our awesome mods that help keep our community on topic and just having fun and enjoying each other's presence, because that's what this stuff is all about, guys. It's about coming together and celebrating spaceflight and celebrating joint exploration and celebrating human achievement, celebrating awesome engineering and awesome science. That's what we're here for. If you're on my channel, you're here commenting, just keep that in mind. We're a close-knit community. We're all here on Team Space. So we're not here to belittle anyone or be negative. We're here to enjoy this awesome moment together, especially this one. This is a big one. This is probably, this summer of Mars is awesome. This will probably be one of the bigger things until we get going back to the moon here with the Artemis program. Will be also extremely, extremely exciting. That'll probably be that and seeing Starship development are big ones that I'm looking forward to this year. Well, not this year, Starship this year, but Artemis program stuff really happening here for the next year. So I for one, you guys know I have a video about SLS versus Starship. And SLS, of course, is the Space Launch System. It's a rocket that NASA's been developing for about 9 years. And I have a long video all about, like, why does that even exist anymore? And I ended up liking that rocket a lot more now than I did before I made the video.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold.
I'm going to make that mono because I'm hearing it only in my left ear.
Flight control, perform launch on time verification. Roger.
Okay, here we go.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
Box 2, verify CISA purge flowing GN2 to the CISA.
Verified.
We're going to Mars.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Denver winds, this is
RLM,
Cape winds on the
verify
METNET.
monitor and event table are in the correct configuration.
This is Denver winds, go ahead.
Verify
We've had termination of LR5 at 60K feet with
RC,
one edit.
verify solar radiation acceptable
Denver
for
winds,
launch.
copies.
Verified.
We're getting a lot of chatter right now. It's in both ears. I wish they were giving us just the go, no go. Oh, that was cool. We had some kind of thing that I have no idea what it is. They're just like, yeah, we're just going to program this rocket.
Launch on time verified.
Roger. LC switch to the ready position. All steps are complete prior to the status check.
Yeah, we're hearing stuff. I'm just kind of waiting to hear more. And then we'll go through our go, no go checklist here any minute. Like I said, the official countdown clock right now, like if you're at Kennedy Space Center, would be in a planned T-minus
8 minutes.
Oh, they're probably about in the hold. Although, wait, they are saying T-minus 8 minutes. Did we miss the go, no go poll? How could they? Okay. Yeah, so thanks for the reminder, Andrew. They do have like L minus and T minus. There's again kind of like what their targeting time is and what their current like countdown net inside of the vehicle. Oh, look, there's a little animal in the water. Bye. Oh, it's so cute. I don't know if you guys saw that or not. But those are sometimes different times. And like I said, ULA does this thing where they'll be in this planned hold, and I believe we're in that right now, which is why they're still targeting an on-time liftoff here for about 7 minutes from right now. So hopefully we have. You guys will have to bear with us a little bit. Our telemetry, we're hoping to be within about 2 seconds.
L minus 7 minutes.
L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Sweet.
Go. Hydraulics. Go.
Oh, here we go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Cetar systems, propulsion. Go.
The
Pneumatics.
first stage is ready.
Go. LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical systems, airborne. Go. Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operations support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety ops.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
I get goosebumps. Oh,
Verified.
man. We're going to Mars this morning, guys. I feel like I should, in that sentence, remind you guys there's no humans on board. This is the Perseverance rover, in case you're just now tuning in.
L minus 5 minutes, 30
So
seconds.
by we're going to Mars.
NSC.
Go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Sweet.
Roger. OS, start list data capture.
Roger.
All right,
All
ladies
steps
and
are
gentlemen.
complete prior to terminal count. LC switch is ready.
It is official. We are going to Mars this morning, guys. And again, this is a flagship NASA mission. This is a big one. This is literally one of the most ambitious rovers that will ever be sent. Has just incredible things. Like I said, it has a drone that's going with it. There's going to be a drone flying around in the very thin atmosphere of Mars. We're going to be producing oxygen on Mars for the first time. Some of the high 21 megapixel color cameras, finally some good, really good high quality images coming from the surface of Mars. So I'm going to turn that down here just for a little bit. This is it, guys. I mean, this is the stuff that I love, that go no go poll. I know it's a little bit old school, but I love that. It literally gives me goosebumps. I don't know. There's just something when you realize, when you hear the teams of people that make this stuff happen. There's literally people that are watching every sensor on this vehicle, basically, and just combing over all the data, making sure it's good to go, making sure the weather's good, making sure there's no boats or airplanes downrange from the rocket, just in case. All right, we're coming up on the
3, 2, 1. Mark.
So that's T-minus 4 minutes now. Hopefully that's pretty well lined up with the clock for you guys.
3 minutes 55.
Ground pyros enabled.
Andrew, can you hear that? And are you able to adjust a little bit accordingly if necessary? Okay, we're going to try and adjust our T0 time to be perfect or really close. But yeah, so this is we're now officially in the countdown. Like, I know it seems weird, but again, that's kind of how ULA does it. So that countdown you just heard was getting into the last 4 minutes. So they're basically like 3, 2, 1. Okay, rocket, in 4 minutes take off. So that's pretty much what they're doing at that point with that portion. So it's a different way of it's not necessarily a different way. This is kind of the way it had always been. But now we're seeing companies kind of do it a little bit differently. Like I said, SpaceX and Rocket Lab seem to have a completely different way of doing things these days. So okay, so this. Oh, baby. I always get a little bit nervous, especially when it's a mission this big.
Securing LO2 topping.
Ooh, I love that shot.
Thanks to flight pressure.
I love those shots.
2 minutes 50.
250.
FTS internal.
Andrew, I think you're a little ahead, aren't you? Try pushing it back probably about 10 seconds. So we're trying to time our countdown clock to perfectly line up because, like I said, there's a little bit of sync issues because we don't get a good time countdown clock from NASA anymore or anything. So we're trying to do it the best we can for you guys, getting you guys a good enough estimate here. But we have to factor in the delay of signal between what we're getting from NASA, what we're getting like from me sending it to my producer Andrew. Yeah, it's pretty hard to do, but hopefully.
1 minute 59.
1:59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
If the telemetry
1
pulls
minute
up
40.
and it's right, I'm gonna lose
Launch
my mind,
enabled.
Andrew.
137.
Okay.
FTS armed.
FTS arm. That is the flight termination system.
1 minute 20.
OCU armed.
SCS count started.
1 minute 15.
Produce ECS for launch.
Roger.
1 minute 10.
Gorgeous morning to go to Mars.
Vent valves locked.
1 minute.
Rock, report range status.
Range green.
Yes, so that's no like boats or anything downrange, or planes even inside of that exclusion zone because they got to keep that path cleared. Like I said, just in case. Well, and even intentionally, the boosters will fall off. Those side solid rocket boosters will fall off, so there cannot be boats
Stable at step 3.
or anything near there. Okay, we're getting close here.
28 seconds.
ECS reduced for launch.
Roger.
25 seconds.
Status check.
Go Atlas.
Go Centaur.
Go Mars 2020.
Yes, I love hearing that. Again, I instantly got goosebumps. Let's do this.
8, 7, 5, 0.
There we go.
Release.
No rocket audio. No rocket audio. No. Oh, well, that is still gorgeous. We all know what rockets sound like. Basically, we'll have to watch another
and
video.
Atlas TU has gone to closed loop control.
NASA, how dare you do us dirty with no rocket audio? Oh, that is gorgeous. So you're seeing a lot of the exhaust right now.
Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good.
They're intentionally throttling down that center engine, the RD-180.
And Mach 1, Atlas V is now supersonic.
Wow. Punching through the atmosphere. You can literally see it on the nose cone there. That shot cone of it punching through the atmosphere as it crosses over Mach 1.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
Maximum aerodynamic pressure, baby. From this point on, the atmosphere is getting thinner and thinner and thinner, right? So although it's speeding up, the atmosphere is getting thinner. So there's kind of a convergent point here where those two things are
Passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good.
So, and most of the exhaust that you're seeing is from those solid rocket motors. And you're actually seeing, I have a whole video about rocket pollution. If you want to know what's actually composed in all of the exhaust, I'll tell you everything that comes out of rocket exhaust from all the different engines, all the different rockets, and break it down exactly for you so you know what's coming out of the back end. But we're coming up here. The solid rocket boosters will be burning out here pretty soon, and then they separate, and then the rocket's just running on RP1, or rocket propellant 1, which is a highly refined kerosene. And we'll see that here just any second. This is a beautiful tracking camera from NASA. Look at that. So get ready for it. There we go. There's a pair of SRBs come off, and then another pair will come off. So now you see all four
indication of SRB jettison,
solid rocket boosters falling off. This is excellent, because if those don't detach, it's big trouble. So now it's just running on that booster engine, that RD-180 rocket engine. That's again, this is RP1. And what's interesting is that, again, as far as talking about the exhaust, you'll notice it's really expanded now. It's really wide, and it's also clear. It's not burning. It's not glowing bright orange like it does at sea level. So if you see the same rocket take off without those solid rocket boosters, its exhaust is bright. Like it's blindingly bright. It's so bright. Because that RP1 has carbon in it, and when that carbon comes into contact with the atmosphere, it continues burning. It's an afterburning effect in the atmosphere. And when it gets higher and higher into the atmosphere, there's all of a sudden no more oxygen for it to interact with. So the only time it's bright is inside the engine chamber, and then from then on out, it has no afterburning effect. So it just gets clearer and clearer, and the only thing we're seeing is a little bit of carbon soot. Just on its own in the exhaust. But it gets wider and wider because there's no atmosphere pushing in against the exhaust. So it's just expanding out. So this tracking camera, this actually might be from a chase plane, because the booster engine of the RD-180, there we go. There's that camera, the booster cam. I love the rocket camera that ULA provides. So we're looking right down, looking at the bottom, from top to bottom of this rocket, of the Atlas V. And we're currently, you can see how dark the exhaust looks there. So that's, okay, there we go. Hopefully, okay, that was fairing deployment. That kind of scared me for some reason. I wasn't ready for that. Oh, good. Yeah, I should have been looking at the timeline. I'm sorry, Andrew. So those payload fairings, now that the atmosphere is so thin, you don't have to have that aerodynamic nose cone on the top of the vehicle anymore. It's completely pointless. So they ditch it to free up, you're not having to push around that heavy thing. That probably weighs several tons, right? So why push that around and waste all that energy pushing something heavy? So they jettison it. And the interesting thing is, it's attached to the first stage. The fairing is so big, it's completely attached to the first stage. And the second stage is inside the fairing. So they detach that fairing while the first stage is burning. And they call their first stage BECO, or booster engine cutoff. Okay, so this is the shot from the second stage engine, the RL-10 on the upper stage, which they call the main engine, because All right, so here we go. This baby needs to light up here. That looks like it's turned on and good to go. It burns completely clear because it is hydrogen. So this is a Hydrolox engine. So oh, look at that. The gimbal steering it. How awesome is that? What a cool shot. So this is of course the RL10 engine. It runs on Hydrolox or hydrogen and liquid oxygen. It's one of the most efficient rocket engines ever built, still to this day, and it's been around in some variation or another since the 60s. It was technically one of the first, I think about the first cryogenic upper stage engine. It was built originally for the Centaur upper stage. So look at it go there. This is what I'm talking about here, guys. So this will do the rest of the velocity maneuver. I think we're probably going to lose out here on our telemetry pretty soon, if I remember right. But okay, so we're still trying to track the telemetry telemetry here, and the second stage actually ends up doing a lot of work. It's just double checking closed loop control, so everything's looking good. So the second stage, like I said, the first stage really helps it get out of the atmosphere and then starts pitching it over sideways. The upper stage engine does a lot of the actual technical work, although it's a little different on Vulcan. To get into low Earth, or Vulcan and Atlas, to get into low Earth orbit, the booster will do almost 2/3 of orbital velocity, and the upper stage will only do the last little bit for most missions. It's an extremely low thrust engine, so the first stage has to loft it up quite a bit and do quite a bit of the work, because otherwise this engine's so weak that if it wasn't, on the right trajectory, it'd kind of end up falling back down into the atmosphere. So they lofted up a little bit more than some other rockets because it's a little bit lower power. And that's the same reason why there's 2 of these engines on crewed missions. So it's honestly a really beautiful engine, though. Very, very bespoke and still rather expensive. But man, is it expensive for a reason, because it's an absolute workhorse and just really does a lot of the power. So what it will do, they'll go into a parking orbit here pretty soon. Once they're in low Earth orbit, they'll be just in low Earth orbit, ready to go. And then at the right time, they'll do the trans-Martian injection. So that'll be the actual burn that raises.
And we did see a minor interruption to telemetry there as we switched to a TDRS compatible data format.
Okay,
telemetry quality is very good.
Here we go. We have data now up on screen, Andrew, from them. Our telemetry may not be correct. Andrew, let's pull our telemetry off screen. Yeah, we're working on it, guys. Our telemetry is off. It's not RIP. Don't worry. Everything's still looking nominal. Declan, what'd you do to us? Flight Club. Our telemetry was pre-programmed, but we do have the official stuff there. Andrew, we might need to move the hour thirds up just a little tiny bit. Just a little bit. But yeah, this is now proper live data. You'll notice the perigee, that's the lowest point in the orbit, is currently negative. So if the vehicle were to stop having its engine fire, and we're seeing, by the way, this little animation, I know people are like, oh, CGI. Well, yeah, it's actually a direct correlation of what is truly happening real time with the rocket. So although it might, because right now it's so far away, it's already almost over Europe, right? And if we're not tracking this, we don't have live camera feeds from it anymore. And this is actually a really good way to know, systems engineers, what's actually happening on the vehicle. So those little things that are on the screen right there, those are thruster firings. And those are real time. That's actually telemetry coming off of the rocket telling this animation what to do. So it's not like it's a pre-programmed animation. It's actually a real-time simulation of the actual data. So you'll see, though, that, and that being said, all the data now on screen is real-time, is real. So the current altitude is 245 kilometers in altitude. The perigee, so the lowest point in its orbit right now, if this engine were to Okay. All right. Sorry about that, guys. We're coming up on MECO, main engine cutoff. So as you can see, the perigee, the lowest point in the orbit, is coming up to 0. That is good. So again, once it's over 100 kilometers, that perigee that's currently negative. Once it's over 100, you're technically in orbit. So they're going to put it into basically a circular orbit here. So you'll see it be like, 245 by about 245-ish. So it might be a little bit, I don't know exactly. So sorry guys, it is my fault here that we're having data issues with the stream. Andrew, maybe we should actually just cut to a full feed from you quick until we get this figured out. It looks like we're still having streaming issues. Yeah, it seems to be buffering everyone's. Maybe. Okay, cool. Okay, well, if we lose it again, we will throw up.
We've had IIT vanish, the Centaur is now orbital. And we've had MECO 1.
MECO 1, so that's main engine cutoff 1.
Centaur will coast for approximately 30 minutes prior to the next burn.
Okay, so now we're in a 30-minute coast, and notice the parking orbit here. It's a little tiny, and this is normal. Hang on, I'm going to listen here. Okay, sorry.
And Centaur is now adjusting its attitude for PTC roll. Body rates and RCS performance look good at this time.
Sweet. So now they're aligning to actually get on the exact inclination, and basically now they're going to be aiming at Mars, essentially. And they're going to be coasting here for about 30 minutes. And like I said, I know it sucks that we don't have a live feed from the rocket anymore. But this is, like I said, this is based off of real-time live data. So the computer simulation here shows what's exactly happening with the rocket engine.
Centaur is 2,400 miles downrange, traveling at 17,300 miles per hour.
That's awesome. So they are circularizing a little bit still with those RCS. You can see the perigee still raising up just a little bit. This orbit's a little bit. Why can't I think of what it's called? Eccentric, or what's the word? It's a little bit where the perigee and altitude is not completely circular. It's too early for me to. Yeah, it's a little bit elliptical. Thank you, Andrew. It's too early for me. It's a little bit elliptical, and that's again intentional. So that you can do a little bit more of what's called a Hohmann transfer. If your perigee, your lowest point is nice and low, you actually get a little bit extra juice on your way out.
13 minutes into flight, the RCS system temperatures have converged to nominal values. The Centaur tank pressures remain at stable and expected values, and still seeing good overall performance from the RCS system.
This is important. So what's going to happen now, basically? And if you guys stick with me, what we'll end up doing here is after this is done, I will show you kind of how to do this in Kerbal Space Program too. I'll play a run through of how to land with a sky crane and everything, do the whole mission in Kerbal Space Program, and we'll teach you all about this stuff. Because what they do is the actual Perseverance is currently on top of the Centaur upper stage. And the Centaur upper stage has to do that trans-Martian injection. So what it's going to do is it's going to do a big velocity change to kick it all the way out to Mars, break free of Earth's gravity, end up going so that the orbit is around the sun, raise the orbit so that it ends up intersecting with Mars's orbit, because Mars is about 1.5 times further away from the sun than we are, right? So it's on a bigger orbit. And so they'll end up raising the orbit around the sun so that the orbit that it's on intersects with exactly where Mars will be on February 18th? Is that what it is? But it's exact time and date. Then this is, again, rocket science. This is the definition of rocket science. It's pretty incredible. So they're basically pointing it to where they're going to need to be firing, and on trying to really, really nail down the inclination just absolutely perfectly, which is the angle. They're trying to nail down everything so it's just picture perfect. And this just makes me really, really happy to see this. And so what will happen is once that Centaur upper stage does that burn, it will let go of the cruise stage. It'll let go of Perseverance, which is inside of an aerodynamic cone and a nose cone, and it has this cruise stage. From there on out, Perseverance will be able to do its own little orbital adjustments and do orbital adjustments all the way to Mars, basically, and make sure that it's constantly aiming perfectly at Mars. And yeah, and so it'll be kind of on its own from there. And then once it gets to Mars, it lets go of that cruise stage. It re-enters not re-enters, but it enters the Martian atmosphere and does the whole entry, descent, and landing progress. And like I said, that is in February. So stay tuned. We will be we'll be here to watch that. That'll be absolutely incredible. So no, what the upper stage is doing right now is it's doing a few things. It's correcting its inclination, getting precisely where it needs to be perfectly, just some fine tuning. And it's also aiming at where it's going to be. By the time it gets back to Earth, it'll stay in this orientation, but it will rotate around the Earth so that it's lined up with its exact heading on the opposite side of the planet, basically. So we still have about 20 more minutes before that burn. The spacecraft will be heading to Mars. So yeah, that'll be at T plus, what is it, about 45 minutes. So we're coming up on that, and yeah, we're coming up on that in about 30-ish. So all right, let's get back to some of your questions. So Betelgeuse, as far as my favorite rover memory launch or landing, I'm pretty fond so far of InSight that took off 2 years ago, because I got to see InSight inside of the clean room out at Vandenberg Air Force Base. And then I watched the launch and the landing of it too. So it's just a mission that I felt had a little bit of personal connection to. That's probably the closest one so far. But yeah, good question. All right. This is from, let's see. Sorry, I'm not even gonna, I totally will mess that up. When do we get the Everyday Astronaut Can't Believe It's Not Smoke t-shirt? I think people would be very confused by that. We're really trying to make, the merchandise we're trying to do is we're really trying to make it so it's like, it focuses on the engineering, except for the pointy end up flaming end down shirt. I will admit is very cheekily has nothing to do with engineering. It's quite obviously a joke, but everything else we're trying to really celebrate the things that people have discovered about Mars and about rockets and full flow stage combustion cycle engines, F1 engines, aerospike engines, kind of focusing on those things because I think those things are pretty darn awesome myself. So yeah. So, but like I said, if you guys want today, if you want 10% off of this Future Martian shirt, which has a big old logo on the back, you can use coupon code LaunchDay by going to shop.everydayastronaut.com. Again, that's shop.everydayastronaut.com. Yes, that'll do it. Shop.everydayastronaut.com. Use coupon code LaunchDay, all one word, lowercase. You'll get 10% off the Future Martian shirt, which, like I said, has all of the details about Mars on it right there for you, including the gravity, the atmospheric composition, and a reminder to always wear your spacesuit if you're on Mars. And then it, of course, has the Arcadia Planatia on the back, which is the Prime A candidate landing site for Starship. Just kind of a fun little nod there. So get your own Future Martian Society t-shirt today. Again, these are hand screen printed. And also a reminder, if you work in the aerospace industry, you can click down here in the link. You can take 25% off of my apparel as a thank you to you for inspiring me to do what I do. You guys are the ones doing the awesome work, and that's a thank you to you. So you can take 25% off. Click there. You can put in your work email, and it'll bounce you a coupon code. And again, that is just as a thank you to you. But we also, like I said, we do have the new full flow stage combustion cycle hoodie, totally updated now, which is awesome because they have like custom sew-in tags and everything. And like on the sleeve, it shows like the thrust and the specific impulse and all that stuff of the Raptor engine. So it's just a kind of a cool nod to the full flow stage combustion cycle engine, which is currently one of my favorite engine cycles. We have brand new keychains as well, and face hole cover NADA masks. So if you need to cover your face hole, we've got you covered literally with Norminal. And then this is actually fun little note here. People don't realize this, but this mask in particular is the exact thing that's on the latch of the International Space Station. So this is, if you were to accidentally open this latch on the International Space Station, it'd be very, very, very bad. And it says, failure to equalize pressure before unlatching can result in crew injury and equipment damage. So we've got that for you guys. So yeah, again, shop.everydayastronaut.com. That helps me continue to do what I do. If you guys want to support me and help me continue making like a cooler everything. More content. We're cranking out content for you guys. The machine is running now. We are up and working on some awesome stuff. And speaking of that, look at this. Alex, I remember this. That's awesome. So if you guys also want to help me support what I do, you can join our awesome Discord channel. Hi, Discord. I love you guys. And by going to patreon.com/everydayastronaut. Thank you to my awesome patrons, and thank you to our awesome Discord community. And again, huge thank you to the mods that are helping keep the chat room clean and friendly and keeping us all together here. So like I said, this is all about exploration. This is about humans coming together and celebrating something for once, because we're just in a world right now where there's a lot of negativity and a lot of division, and spaceflight brings us together, and we can all come together and celebrate something. This is like all of us celebrating for the same, cheering for the same team, hashtag team space. This is what I'm talking about. So this is the fun stuff. So if you guys want to join our community, patreon.com/everydayastronaut. And of course, welcome to all of you. If this is your first time viewing, welcome. Thank you for joining us this morning, seeing an awesome mission to Mars. So let's get back to a few of your guys' questions. Fallen Gaming. Hey, Tim. Got my coffee, keen to watch the launch and Mars. Can't wait for Elon to place an upside-down rocket on a pad to fool us all. If he ever trolls us with a flamey end up, pointy end down, it's going to be a scary, scary day for me. I don't know what I'll do. Thank you, Fallen. This is from Geradiel. Thanks for your awesome videos. Greetings from Germany. Thank you. Hello, Germany, or hello, guten Morgen. I just exhausted all my German. Let's see. This is a great question from Dermax HD. Can the Falcon 9 or Falcon Heavy get to Mars? If so, why don't they use them this time? Dermax, that's a really, really good question. So as far as Falcon Heavy goes, it could have easily done this payload. It's well within its capability. But it's only flown 3 times. And although it's been completely successful so far, sans being able to land the center core, but landing is totally ancillary. It has nothing to do with deploying the payloads. It's been completely mission successful, a flawless rocket so far. But when you're putting literally $1 billion Mars rover that has taken almost 10 years to build, that's really when reputation and reliability matters. And this rocket, the Atlas V, has just been, it's 100% success rate. So you can't argue with that. And that's worth something. That's tangibly worth something. And so that's why these missions are launched on top of the Atlas V, just because it's been an absolute workhorse. As far as Falcon 9, if Falcon 9 expendable would probably be able to do a mission like this. I don't know if it can get that. It's a lot of payload going to Mars. It probably could. An expendable, you could probably do it on a Falcon 9. But again, the vehicle, they kind of choose the vehicle when they're designing the spacecraft, right? Those two things are kind of hand in hand. And at the time of making the decision to use the Atlas V, again, even at that point, the Falcon 9 was probably not certified for a mission like this, a flagship mission. It wouldn't have been certified, wouldn't have had enough flights under its belt to be considered worthy at that point of, again, $1 billion Mars rover. So now, hopefully, in the near future, SpaceX will win a few more of those missions that are within their performance characteristics. But at the same time, like, this is ULA's big selling point, is like, listen, we got this. Like, that's their thing. It's like, we got this. You can come to us. Like, if you need to get to Mars, we'll absolutely get you there. So that's kind of their selling point, and that's why they're good at what they do. That realistically, at the end of the day, price doesn't matter almost if all that matters is getting your payload to where it needs to go, right? So that's kind of always been their selling point, and they've proven that through 140 some launches or whatever now. Just absolute reliability. So yeah. Shem Jerry, that's more of an Andrew Tay question in our Discord. I can't actually move anything on screen, but they are requesting that the T clock moves a little bit to the left. It's more a scaling thing with the video that we have right now. It's the video is like all cropped in and weird. Actually, what NASA is sending us right now is literally a computer monitor, because you can see like the Windows 98 style like bar at the top of it. That's not us. That's the feed we get from NASA, because unfortunately, NASA and ULA, it's still just kind of this old school system. If it's not broke, don't fix it type of thing. So yeah. That's true. Yeah, we should mention Dr. Raptor has a really good point in our Discord. It's only 100% reliability on the Atlas V. The Atlas has been around forever. So if you look back at like the original Convair SM75A, the original Atlas, of course, back in the early days, reliability was horrid, like 50% reliable. But nowadays, after iterations, by the time we're like to the Atlas III, it's an incredibly reliable rocket. And then, yeah, now Atlas V is just literally 100% reliable, 100% mission success. So yeah, there you go. Steve Williams, thank you so much, Steve. Here's a donation for the next bunch of launch streams. Have you seen Gilmore Space based on the Gold Coast in Australia? I have not ever seen Gilmore Space. Hang on, I'm listening real quick.
RCS system continues to settle propellants in the tank. Still seeing stable Centaur tank pressures as well.
Cool. Well, everything's still looking good. That's important. Just wanted to check in and make sure we're hearing from them. But no, I've not seen Gilmore Space. If I see it pop up on something, I'll check it out. But I do love Australia, New Zealand. I need to visit Australia. I've been to New Zealand, loved it. I could have spent weeks there. New Zealand's incredible. I want to do someday like a full month where I spend like 2 weeks in Australia, 2 weeks in New Zealand. I don't think 2 weeks in Australia probably wouldn't get me much. I'd probably have to stick to one coast, but yeah, I gotta see that. I'm just, everyone that I've ever met from either of those places are some of the nicest people. There's just like this chill attitude on the Southern Hemisphere. I don't know what you guys do, but you got it made. This is from Ayub Beer or Libier. I'm sorry, I'm totally off. I really apologize, but thank you. Can Perseverance take and use parts from Curiosity to repair itself to go goofy out there? So literally on the surface of Mars, could Perseverance go up to Curiosity, steal parts off of it with its robotic arm? The answer is no and no and no, unfortunately. They're pretty far apart on Mars, and don't forget the maximum cruising speed for these things is something like, what is it, like less than 0.1 mile an hour or something. That's their maximum speed, because they don't want to run into any rocks or do any damage to the vehicle. So and the lifespan of the RTG, is only designed for about 3 Earth years. Is that what it is? 3 Earth years, a year and a half on Mars. But the sad thing is, I think it would run out of power before it could even get to Curiosity, because Mars is still big. Mars is really, really, really big. And if you're traveling at, 0.1 mile an hour straight continually with running into obstacles, getting stuck in sand, all that stuff, I don't think it could do it even if it went all the way. And then it has this arm. I don't think it could. The answer is no. The answer, sadly, is no, although that would be awesome. Someday, maybe, future Martian society people that are living on Mars can go visit those 2 rovers, put them in Martian museums and stuff like that. But as far as part swapping, probably not. Great question, though. Thank you for that. This comes from Matthew. Thank you so much. Oh, we found out why the telemetry was off in our webcast. Newsflash. We're tracking the booster. It was not Declan Murphy's fault. Everyone, Declan Murphy from Flight Club, I owe you a huge apology, my friend. We accidentally were tracking the booster's telemetry. So that's why it stopped. And that's why it went down. That we were tracking the boosters. So people wanting to know the boosters' reentry velocity and all that stuff. Now you know. But we accidentally were doing that, and we didn't switch over to the second stage. So that makes a lot of sense. Sorry, Declan. We apologize for making you look like a goof. It was not intentional, but that's why the live data here on screen is currently correct now. So how close are we, though? Let's keep the official stuff up. Although that does at least show us where we're exactly at right now, because what's on screen with NASA and ULA is the perigee and apogee, but it doesn't tell you where you're at in that period. And so it is actually going to be decreasing in altitude at this point, because it's going from its highest point to its lowest point in the orbit. So you are kind of falling, believe it or not. You're also speeding up a little bit. And that has nothing to do with the fact that it's pointing down. It could be pointing anywhere right now. It could even be firing those little thrusters up. It'd still be slowing down. Like, that's just how orbital mechanics work. If you're at your lowest point in your orbit, that's your fastest point. Your highest point in your orbit is your slowest point. Just like a roller coaster, if you're going up and down on a roller coaster, how at the top you're like, and then at the bottom, it's that same thing. So in your orbit, you're going really fast at the bottom. At the lowest point, you're going a little bit slower at the top point. And depending, if like you're right about to break free from gravity, from the body that you're orbiting, you're going really, really, really slow. And then at your highest point. So you'll like literally almost stop and you'll be at the top. Again, just like a roller coaster on a really big hill, you get to the top and if it just barely makes it and then you're like, whoa, you know, same thing. It's the same physics, which is really cool to see. So even though, you know, our telemetry, yes, it is actually pretty much going downhill. So once it gets down to about 160 kilometers or so, that's when it will begin its trans-Martian injection. So that is actually correct. That is correct telemetry. Pretty cool, right? Pretty cool. This was, sorry, I think I missed this from Matthew. I do apologize. Matthew, NASA and SpaceX need to hire you to do their launch commentary. For reals, thanks for being awesome. Thank you, Matthew. But, you know, I'm already doing my dream job. Like, I like that I can do my own thing. I can cover whoever I want, whenever I want, whatever I want. I can cover, you know, different nations. I covered the Chinese launch to Mars. I covered the Japan/UAE launch to Mars. Like if I worked for NASA, if I worked for SpaceX, I couldn't do that. And the point of my channel is to bring space down to Earth for everyday people. Is really to help cover and lift up and highlight literally everyone. And I know I haven't been very good at that always internationally, but I'm trying to do that. I'm just very comfortable with United States vehicles. Just, you know, that's kind of where I started, was with SpaceX, branched out to ULA and Rocket Lab, and Blue Origin. But I'm really starting to get more and more familiar with more launch providers. I still need to get way more familiar with Roscosmos and get ready to do some of their launches, because I've still never done, I don't think I've done a single Roscosmos launch. But thank you for the, that's really nice of you, Matthew, but I'm already taken this little hobby and it's already an absolute dream job for me. So I'm already just doing I'm living the dream. You couldn't pay me enough to work for NASA or SpaceX, because I almost said Nasser. Did I just move to New Zealand? You really honestly probably couldn't pay me enough to work for those companies, because I love this. I can do long rabbit hole research things on the Aerospike engine, and then do a hour-long documentary on Aerospikes if I want to. And I did, and I love that. And that's what's fun is pursuing and doing my own thing. So, wherever the wind takes me, I'm a free spirit. So thank you. Johnny Vlogs 416. Hey, you are great. You are great bringing space down to us. Thank you so much. I really appreciate that, Johnny. This is from Mark. Jurassic Park car from our Ludicrous. Dude, Mark, how's it going? From our Ludicrous Future and Discord. See you later today in the podcast. It's going to be a long day for me, Mark. Yeah, because I'm going to record a podcast here in about 4 hours, 3.5 hours already. That comes out tomorrow. So again, like I said, if you guys want more of me, you want to learn more about spaceflight or get the space news, the news of the week, I do it every single week. olfpod.com. That's our Ludicrous Future podcast. We have it here on YouTube. We also have it on whatever podcast app you listen. I talk about space each week. We also talk about like EVs and futurism and stuff, and science. So if that's your type of thing, definitely subscribe to that podcast. It's a lot of fun. We're coming up on 50,000 subscribers. I really would love to see 100,000 before the end of the year. I know it's not going to happen, but please just try to tell me that it's okay and that maybe we can do that. That'd be awesome. So thank you so much, Mark. Great question here from Alex G. Tim, are you going to be covering the DM2 undocking on the first and splashdown on the second? I'll probably only cover the splashdown, because the undocking is unfortunately really, really, really boring. And I'm going to be, the undocking is like, wait. And then like, they undocked. Okay. Like it's not that thrilling, but splashdown, I'll definitely cover splashdown. And like I said, I'll have a video going over the exact timeline, all the events, how you deorbit, how you survive reentry, how heat shields work, how the little thrusters work, how the parachutes work. It's a pretty intensive. It is a little bit, it's kind of specific to the Dragon capsule because we use that as an example. But at the same time, it's applicable to basically every vehicle as well. So
10 minutes remaining in this coast period of flight. Continuing to see good performance from the RCS system. Good response in Centaur body rates as we reverse that passive thermal control roll direction. Also seeing stable Centaur tank pressures and overall excellent performance from the telemetry systems.
Beautiful. Beautiful, beautiful. We have a request here, Andrew, in our Discord that they would like the telemetry to not overlap. Could we actually move the whole overlay down a bit? Or we could even, let's try putting it to the left of me. Or no, that would probably interfere with the comments. Oh, Andrew says not easily. Let's go ahead and pull off our telemetry quick again and just put theirs up since we're coming up on the live telemetry here. So we're gonna take ours down so it's not a total number jumble nightmare. All right. So yes, I will be covering that and get ready for a video hopefully before that. Andrew and I are gonna have to work our absolute butts off to get that thing out to you guys in time. So yeah. This is from Carol says, almost missed departure. Prepare your boarding passes. Who else is on board with me? Yeah, that's right. Did you have your name on board Perseverance? This is something that NASA did. It's pretty cool. So you actually, they took millions of names. I don't remember, on these little silicon chips, and they're like laser etched or something. So you could have your name on Mars, which I think is really, really, really cool. So, yeah, I hope that there's a few of you out there in the chat that actually did have your name on that. Someone asked real quick, what's the name of the podcast? The podcast, again, Our Ludicrous Future. You can also find it by going to olfpod.com. olfpod.com. You'll find all the links to whatever you want, YouTube, podcast players, Spotify, all that type of stuff. So, yeah, olfpod.com. Let's see. It looks like a lot of people have their name on it. That's awesome. I love seeing that. That's crazy. That's super cool. All right. This is from Hanzova. Says, hey, Tim, how did you make that giant glowing moon in the No Photoshop series, the one where you're feeding the moon? So that was no longer part of the No Photoshop series. I actually have you know what? There's an old video out there. If you look up Tim Dodd iPhone review, it was literally before I started doing YouTube. I did a video reviewing. It was the first time that you could shoot RAW on the iPhone. And as a professional photographer, I wanted to look at like how those images compared to a DSLR. It was kind of like a joke. Like, we're going to compare a 46 megapixel Sony A7R II at the time versus it was like I think it was like the iPhone 7 or something. And we're like, we're going to see how a phone can do. So I shot a bunch, and you can actually see how I did all those photos. But that was a little bit post Photoshop, or that was like post my No Photoshop series. For those of you that have no idea what I'm talking about, this whole project, Everyday Astronaut, started as a photography project. Literally, like, I bought a spacesuit as a joke, kind of a Russian high-altitude flight suit as a joke. And as a professional photographer, I started taking pictures of myself in the suit in all these like willy-nilly, haphazard ways, and like kind of like stuck on Earth. You can find it still on Instagram. If you look at old Everyday Astronaut posts on Instagram, you'll see the old series. And that's actually what made me fall in love with spaceflight, was that series. I was, researching, trying to hide Easter eggs in all my photos and making all the photos have some kind of big, grand, fun, ridiculous meaning. And in the doing of that project, I fell in love with spaceflight. But the first series was super Photoshop. The second series is the one that was no Photoshop. And then after that, it transitioned into kind of back to like Photoshop. So that series, I made a big giant moon ball, put a light inside it, a flash, and was able to make it so it like glowed, even though the moon doesn't technically glow, it just reflects. So, but I wanted it to have this like ambiance. And this is before you could buy those big 3D printed moons. Or I actually tried to buy a 3D printed moon, but it was going to be $500 plus like $800 shipping. And I'm like, yeah, no, I'll just Photoshop it. So I just ended up Photoshopping the moon into those particular images. So you guys can find all those old ones on my Instagram still. They're way back in there. You might have to go back in history, but I still enjoy those. I wish I had time to do that type of stuff, but I also pretty much ran out of ideas. And have a lot more fun making YouTube videos these days.
From the Centaur main vehicle batteries, stable voltage and temperatures. Also starting to see a little bit of a response in Centaur body rates as we start to turn towards the MES-2 attitude.
Cool. So they're just literally now pointing it. So they've done literally a thermal roll. So they roll the stage a little bit to prevent it from getting too hot in certain areas. Because as you know, there's no atmosphere in space. That's why you're in space. So there's no conductivity. There's no air to actually, hold and trap heat. So the side that's facing the sun is really, really, really hot. It gets really hot. And the side that's not facing the sun, that is receiving no radiation from the sun, is really, really cold because there's nothing touching it. There's nothing to make it hot. So you get these big temperature gradients. So they roll the vehicle to keep it like thermally stable, basically. Yeah. Okay, so here's from Adam Ferran. Hey, Tim, thank you for all the awesome and informative content. Your channel has helped me decide to pursue a career in space industry. See, this is what I'm talking about here, guys. That is awesome. Go Atlas, go Perseverance, save Space Camp. Yes. Again, for those of you watching, go to savespacecamp.com. Space Camp, the Space Camp is in trouble because of the pandemic. They have had a whole year with no income. They're not getting any federal funding, any grants, nothing. Like they're literally just running out of money, and they'll be out of money by October. If you ever have dreamt about going to space camp yourself or dreamt of your kids or your future generations going to space camp, experiencing that, we're at risk of that never happening again. So again, savespacecamp.com. Let's make sure that's around. It's an awesome thing for people from all around the world. People come from all around the world to go to space camp. So yeah, save Space Camp. I love it. Thank you, Adam. Timothy Matthews. Won't radiation on the surface of Mars kill life collected from boreholes while they're waiting for pickup? So not necessarily. First off, they're not necessarily looking directly for life. They're looking for signs of past life, because so far all indications show that there is no even microbial life. And any life that would exist on Mars would be able to handle higher radiation tolerances anyway. It'd probably be a very different life form than what we're used to seeing. And it can probably handle high amounts of radiation. And inside those tubes, you're still looking at being inside on the underside carriage of a vehicle that is has a lot of. We're about 3 minutes here from Centaur upper stage for the actual injection to Mars. I'm going to listen here.
An oxidizer pre-start sequence, and this burn will last approximately 8 minutes.
So that's why so the engine, like I said, the RL-10, very low power, but extremely efficient, like over 450 seconds of specific impulse for those of you that are rocket engine nerds like me. It's one of the most efficient rocket engines available, but it's very low thrust. But what it lacks in thrust, like I said, it makes up for in efficiency. So it will be a full 8 minutes of burn time to actually inject itself, to break free of Earth's gravity and get itself out there to Mars. So, yeah, pretty wild stuff, honestly. So, yeah, so as far as life on Mars, again, I'm not a planetary scientist. I don't know, but it'd be still, inside a tube, a metal casing, which would provide some radiation shielding, while it's sitting on the surface of Mars. So anything it's been exposed to on Mars, it'd still be exposed to. And we're not likely going to have like straight up any kind of signs of life there. So, anyway, so. Good question. I wish I knew more about that, but yeah. This is from Dennis. You can nuke the Mars. I mean, the poles, obviously, in Earth. That's true. By the way, would nuking Mars really work in real life, or is this just a fantasy? Is this real life, or is it just fantasy? I mean, I think it works. I think theoretically it works, but I think it would take a lot of nukes. Like it would take thousands of our nuclear arsenal to make any kind of impact on actually changing the climate and atmospheric composition of Mars. Likely not going to happen, but I think there's been. Oh, here we go. They're settling the prop.
Still seeing nominal temperatures and loop pressures in that system.
All right, so they're settling the prop. So now you'll see the RCS systems firing directly prograde, directly forward. That makes sure all of the fuel, because it's 0G, all the fuel will be pushed into the back and settled into the bottom domes of the tank, so that when they start up the engine we can't have the engine ingesting any air bubbles, right? It has to be injecting and ingesting this liquid rocket fuel, which is liquid hydrogen and liquid oxygen. So they have to be burning right now to settle it until they fire the engine. Once the engine's firing, of course, the engine will be pushing and settling that fuel the rest of the way. So we're getting really close here. This is from fuel pre-start on RL-10. So they're getting ready. From the Martian engineer. Hey, Tim, so many live streams lately. It's great. If you want to learn more about the helicopter, my new video is chatting with the chief pilot. That's awesome. The Martian engineer. We need to learn about that. That's really cool. All right, let's stand by here for engine ignition. Looks like it's in startup. Looks like it has started up. Or is in startup. There we go.
And we have main engine start too.
Yeah, baby. There we go. Main engine start 2.
The RL-10 pressures look stable and nominal at the beginning of the second burn. And
okay, so this is an 8-minute burn. And again, what's going to happen is this is going to take... So right now, again, Perseverance is at the top there. It's inside of its aero shell. It's got a heat shield there, and it's got also a cruise stage. And this cruise stage is really important because it's going to detach from the Centaur upper stage after this 8-minute burn. And
system is in closed-loop control.
And we're in closed-loop control, so it's aiming, just perfectly aiming at Mars right now. Or not at Mars. It doesn't aim at Mars, actually. It aims at the Mars trajectory. So what it has to do is it has to break free of Earth's gravity first by raising the orbit around Earth until eventually that orbit snaps, basically, and ends up putting it into an orbit around the sun. Once it's in orbit around and this is all continuous. It's all one burn, but it's kind of like, if you've played Kerbal Space Program, you know what I'm talking about. Like I said, I'm going to try and do that here after a short break after payload deployment. So once the orbit kind of snaps, all of a sudden your orbit's going out around the sun, and now you're raising your orbit around the sun to intersect with Mars. Now the thing is they actually intentionally miss. When they're going to Mars, they intentionally miss a little bit because they don't want that Centaur upper stage to go to Mars. The Centaur upper stage is not sterilized. It's not ready to go to Mars. It's not intended to go to Mars. So they intentionally miss a little bit, well, a good amount. And then that cruise stage that's attached to Perseverance rover is, on the backside of that aero shell, kind of in between where the rocket starts to taper down, and then there's that like gray ring. That's all part of the cruise stage there. That will redefine it and like help tune its trajectory and change its course to actually end up hitting Mars after its 6.5, 7-month journey or whatever. So yeah. So that way the Centaur upper stage misses Mars, and just the stuff that's intended to hit Mars hits Mars. So at what altitude will the apogee get to at the end of this burn? Curious how high it goes. So that's what's I'm interested too, because it'll break free eventually and go from Earth-centric altitude to a heliocentric, so around the sun. And I don't know if that shows in the live telemetry. I don't know what's going to happen here, so I'm curious. I have never really thought about that and paid too much attention. So let's watch. Let's find out. Let's learn together. That's the beautiful thing about this. Good question. So, all right. So, let's see. This is from Adnan. Is there any difference between ICPS and DCSS? Does the interim cryogenic propulsion stage have the expanded nozzle? So they're asking the question. Okay, so I had to frame this for a second. This is a question about the upcoming SLS rocket that NASA is basically building and designing, with ULA being a part of it, with providing the upper stage, Boeing the prime contractor, Northrop Grumman, a whole bunch of Lockheed Martin, a whole bunch of people involved in the SLS and Orion project. And the question is there a difference between the interim cryogenic propulsion stage, which is currently what's going to be the upper stage portion of SLS, and the Delta cryogenic second stage, which is the upper stage of the Delta IV and Delta IV Heavy rocket? And yes and no. They're very, very, very similar. They're slightly different. There's some small tweaks. I believe the oxygen tank is actually a little bit bigger on the interim cryogenic propulsion stage. The adapter that adapts it obviously has to go from 5 meters out to 7.5 or 8.5 meters wide. So there's a different adapter. It still has that RL-10 2B engine, which is the one with the extending nozzle. So it does have that extending nozzle, which is a really cool thing. It's a nozzle extension that makes this nozzle look small, believe it or not. It's this huge, it just keeps going and it keeps directing that flow. So that actually is the most efficient upper stage engine, I believe, at least currently flying. That's not like nuclear or anything or ion, but as far as the chemical propulsion, it's up there. It's very, very, very good. So they're very, very similar. There's some other small little tweaks here and there, but it's not the same directly as the DCSS, the Delta Cryogenic Second Stage. Although it virtually is. It is and it isn't. Small tweaks. There you go. Hopefully that answers your question. I do talk about that a little bit in the SLS versus Starship video. So if you need to know more about that, check out that video. I kind of go over all those details. Garib, how's it going? Hey Tim, it's tea time in India. It's coffee time for me, baby. It's time for more. My throat hurts already because I talked all last night shooting a video. Oh, it's gonna be a long day. Oh, real quick, I'm going to look at that altitude. Cool, everything's looking good so far. We have a new member from the Sponko Matt. I like that name. Sure. That's awesome. Thanks for the membership. Vincent says, I would have loved to see a Falcon Heavy launch this. Again, it technically could have, but it's a relatively unproven rocket as far as when you're dealing with $1 billion payload to Mars. Maybe Falcon Heavy can win some contracts like this in the future. It's that same type of thing. By the time we're used to Falcon Heavy and Falcon Heavy's flight proven and flying flagship NASA missions to Mars or Jupiter or something, by that time, Starship will be flying. But they choose the vehicle like way ahead of time. It's not, so this vehicle was chosen probably 5, 6, 7 years. I don't remember when exactly they won the contract, but Loopy or someone in our Discord knows when exactly this vehicle was chosen, but it's years in advance. So it's not like they're just going to switch because a new rocket came online. Like, oh, wait, that one's cheaper. Let's do it. Like I said, what matters most is mission success. And if you want mission success, you choose a rocket that's been 100% reliable. And that is the Atlas V. So it's expensive. It's more expensive. It's 2-3 times more expensive, maybe even 4 times more expensive than Falcon Heavy. But at the end of the day, it's proven itself. It is proven, and it is absolutely knocking this mission out of the park as it does. That's just what you get. Apogee, here we go. Apogee's screaming. Let's see what happens when it breaks. It'll break pretty soon. So notice that Apogee's increasing very quickly because it'll end up. Here we go. Is the Apogee going to snap, or what do they do? There we go. So we don't get to see the Apogee, the actual change once they're going heliocentric. So their computer systems and data do not show us that. Great question, though. So yeah, that basically snaps. So now at this point, if it lets go, it's going to be stuck around the sun. So it's still burning so that it raises its orbit around the sun to intersect with Mars. So it is now technically, as soon as even if the engine cut off right now, it's going to be orbiting the sun. It has broken free of Earth's gravity. And it's in escape velocity. So it would never really come back to Earth at this point. And it's continuing to accelerate so that it raises its orbit around the sun to reach Mars. And again, I'll show you something. I'll show you this in Kerbal Space Program. We can play that real quick. I'll do a quick Mars mission, a quick recreation of that just for fun after a quick break. So we're waiting to hear good confirmation because they just cut off the engine.
Sorry, seeing turn to the separation attitude. RCS system performance looks good as we do that, and so do Centaur body rates.
So I'm waiting they might say like nominal insertion, but shutdown they said was good. So hopefully, assuming they knocked it out of the park, because again, that's kind of ULA's thing. Is like, we're just going to nail this. Bullseye, as Tori Bruno would say. Really hoping to hear that call out.
A little under 4 minutes remaining until Mars 2020 separation. Continuing to see good performance from the telemetry system, getting all around good data. Also seeing nominal battery voltages and temperatures.
Cool. So everything's still looking good. So like I said, they're basically going to get into this separation event, and they'll detach the crew stage and the spacecraft. So that's in that, like I said, it's in that aero shell. It's in that inside that heat shield there. They'll detach from it, and then I believe that's going to be the end of their stream. And then I'll show you how this whole thing worked in Kerbal Space Program, just for fun. I'm still going to keep listening in here. This is from Will Canavan. Hey, Tim was listening about lava tubes before and had some questions. What are they? How are they formed? Lava, and how big are they? Will, I don't know too much about that, but they are literally from molten lava when the planet was made. They don't necessarily have active volcanoes on Mars, so these are former volcanoes and former lava tubes that existed at one point on the Martian surface. And unfortunately, that's about all I can tell you. They can be, I know they can get big. Like you could fit a building inside some of them. And that's something that I hope we explore soon is some of those lava tubes. That'd be really, really cool. But I don't unfortunately know too much more about it. Again, not a planetary scientist. But yeah, a new member from Apollio. Thank you so much, Apollio. I almost read Polo. And Deadpool. Thank you so much, Deadpool. Love your movies. This is from Ali Ahmadi. Says, hello from Iran.
2 minutes remaining until spacecraft separation. Still seeing very nominal performance of the RCS system. It's controlling Centaur body rates very well.
Awesome. Everything's looking great. From Ali Ahmadi, I have to admit, I don't remember if my name is actually on board or not. I remember doing it for one of them, and I don't remember if it was that one or if it was Insight. I should probably find out. I think you can go to NASA and find names.
And
so someone
seeing an increase in Centaur roll rates as Centaur spins up in preparation for spacecraft sep.
Okay, so they're spinning the stage in preparation of spacecraft separation. Let's see. Melbourne, Australia here. Can't wait for local news. I hope your local news is great. Let's see. Kiwi here. Not all Rocket Lab jobs involve ITARs. See, there we go. There's a fact. So yes, if you want to work for a rocket company, to the person that mentioned not being a U.S. citizen, not
a little
being able to
less
work.
than 1 minute remaining until spacecraft separation.
Okay, less than a minute. Not being able to work for SpaceX or Blue Origin. Yeah, definitely check out Rocket Lab or check out some of the other international companies too. But yeah, I know for a fact, Rocket Lab, some of them in New Zealand do not involve ITAR. So, Josh B.
And about 30 seconds until spacecraft separation, still seeing stable Centaur tank pressures, very good performance from the RCS system, and stable indications from the avionics systems as well.
Awesome. Josh B., should we be concerned that the Starlink launch has been delayed so long? Thanks for the stream. It is weird. It's unusual. I don't think it's concerning. What would be concerning is if they had launched with some known issue. So they obviously don't have go fever for that Starlink mission.
And we have successful separation of Mars 2020 with the Perseverance rover.
Yeah, baby. That is awesome. That is awesome. They did it. I'm waiting to hear, I'm assuming everything's totally nominal or nominal if you're like me. That is so great. Congratulations to the teams involved. That is huge. Oh, I'm so glad that went well.
And with the successful separation of Mars 2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
Again, all right. It's just us now, guys. So that's going to be it for the official stream from NASA and ULA. But I just wanted to give a big old fat shout out to NASA and ULA for just knocking this thing out of the park. We cannot wait for February for that incredible, entry, descent, and landing. That's going to be huge. Sorry, I did pause this, Andrew. I don't know if you want to pull me up full screen here, but yeah. That is a huge congratulations to the teams involved. It looks like you guys just knocked it out of the park as we expected. Stand by for February when this thing actually reaches Mars. And like I said, I will be doing a live stream for you guys. I'll have you covered and it'll be awesome. The entry, descent, landing is definitely really intense. You're definitely going to be crapping your pants because there's a 20-minute delay between the communications of Earth and Mars. So everything that we're hearing and seeing is 20 minutes after the fact. So it could have very well smacked into the surface of Mars, and due to the laws of physics and the speed of light, we won't know for 20 minutes later. So it's just I don't know. There's something about that whole thing that is awesome. So it's going to be great. And like I said, I do have a video about that whole thing. So if you guys want to know more, Perseverance versus Curiosity, I compare the two and I show you how the entry, descent, landing works. I do a lot of things there. And like I said, I'm actually going to pull up some Kerbal here in a little bit, Kerbal Space Program. I'm going to show you guys how exactly that does work, and kind of how you get to Mars, all the things involved. We have kind of a cool Kerbal version of this mission, so I'm going to play along, show you guys all the things really quick. But I'm also going to take a little break because I've been talking way too much this morning already while I get that kind of pulled up and ready to go. Let's see. Meantime, I'm going to answer a few more questions and get to break. But also, like I said, we do have one more thing here while I pull up Kerbal. Again, if you guys want to support what I do, consider going to shop.everydayastronaut.com. Get your own merchandise. Like I said, we do have 10% off the Future Martian t-shirts today by using coupon code LAUNCHDAY. So again, shop.everydayastronaut.com. Get your own Future Martian t-shirt. Super, super cool. And again, of course, we have, like I said, we have brand new full flow stage combustion cycle hoodies. We have brand new keychains, and of course, we have like full flow. We've got it all. We got it all. We got you covered for face hole covered Nada masks. We got you. So shop.everydayastronaut.com or everydayastronaut.com/shop, whatever, same thing. That helps me continue to do what I do. And of course, also, if you want to help me do what I do, go to patreon.com/everydayastronaut for access to our Discord channel, which is an incredible community of people. Genuinely, just love these people. They keep me sane, and they've been a really, really good company during during the times here, especially with some of the pandemic stuff when it's been kind of hard to, find community. So thank you to Discord and all you guys that are awesome. But if you guys want to join, patreon.com/everydayastronaut, that continues to help me do what I do and make more and more upgrades to everything I do, constantly tweaking, constantly iterating, working on making the best content for you guys at all costs. So thank you guys for everything. So patreon.com/everydayastronaut. I'm going to take a little bit of a break here. I'll try to answer some of you guys' questions. Oh man, there's a ton here, but I'm going to try to answer some of you guys' questions, and we're going to get Kerbal Space Program all pulled up for you guys, and I'll be showing you guys that as well. So I'm going to take a 5-minute break. You're going to see a thing kind of loop a little bit. I'm sorry, it's going to be on loop. It'll be on repeat twice, but please stick around. It'll be really fun to do Kerbal because I'll show you guys something, and we'll be right back. So bear with me.
Rocket science, a term we all use to describe something incredibly difficult, and rightfully so. I mean, just look at a rocket engine. Stare at it too long, and your brain might melt. Trying to grasp all the concepts involved in rocket science can be incredibly intimidating, and yet rockets were designed and virtually perfected in an era when computers were the size of a room, and most calculations were done with paper, pencil, and a slide rule.
Touchdown confirmed.
The sheer brilliance of the people who have figured all the stuff out blows my mind. I, on the other hand, am a prolific college dropout. My name's Tim Dodd, but I became known as the Everyday Astronaut when I randomly bought a Russian spacesuit as a joke, took pictures of myself with it in just about every imaginable situation all around the world in a viral photo series. And in the making of that series, I fell head over heels in love with spaceflight and space exploration. When I started the photo series in 2014, I could barely tell you the difference between a space shuttle and a Saturn V, but my appreciation and curiosity for the subject grew into an obsession. Before you knew it, all I wanted to do was learn more and more. And the more I learned, the more I wanted to share what was making me so excited. But as someone who dropped out of college and has no technical background or degree, I really felt unqualified for the job of explaining rocket science to anyone. But the fact of the matter is, if I can learn this stuff, anyone can. So now, through endless curiosity, an absurd amount of questions, and very little sleep, I obsessively strive to actually grasp all the complexities of rocket science.
Yeah, baby!
But this isn't just some basic surface level information we deal with here. Nope, we dive in deep. We get into all the nitty-gritty details that engineers spend years going over. I'll take you behind the scenes of the most exciting missions.
Not a bad sight.
Get up close and personal with the coolest hardware. Talk to the smartest people I can find, and break down incredibly complex topics. Because, quite honestly, it's a lot of fun. Besides, with every mission, there's thousands of talented and motivated people working their hardest to ensure mission success. And this truly is the goal of Everyday Astronaut, to cheer on and lift up the people doing the hard work. We're living in exciting times, where the pace of innovation is faster than we've ever seen. where the cost of spaceflight is coming down by orders of magnitude, where the people living today will explore new worlds amongst the stars. The point is, rocket science is awesome, and you don't need to be a rocket scientist to be excited. Everyday Astronaut, bringing space down to Earth for everyday people. Rocket science, a term we all use to describe something incredibly difficult, and rightfully so. I mean, just look at a rocket engine. Stare at it too long, and your brain might melt. Trying to grasp all the concepts involved in rocket science can be incredibly intimidating, and yet rockets were designed and virtually perfected in an era when computers were the size of a room, and most calculations were done with paper, pencil, and a slide rule.
Touchdown confirmed.
The sheer brilliance of the people who have figured all this stuff out blows my mind. I, on the other hand, am a prolific college dropout. My name's Tim Dodd, but I became known as the Everyday Astronaut when I randomly bought a Russian spacesuit as a joke, took pictures of myself with it in just about every imaginable situation all around the world in a viral photo series. And in the making of that series, I fell head over heels in love with spaceflight and space exploration. When I started the photo series in 2014, I could barely tell you the difference between a space shuttle and a Saturn V, but my appreciation and curiosity for the subject grew into an obsession. Before you knew it, all I wanted to do was learn more and more. And the more I learned, the more I wanted to share what was making me so excited. But as someone who dropped out of college and has no technical background or degree, I really felt unqualified for the job of explaining rocket science to anyone. But the fact of the matter is, if I can learn this stuff, anyone can. So now, through endless curiosity, an absurd amount of questions, and very little sleep, I obsessively strive to actually grasp all the complexities of rocket science.
Yeah, baby!
But this isn't just some basic surface level information we deal with here. Nope, we dive in deep. We get into all the nitty-gritty details that engineers spend years going over. I'll take you behind the scenes of the most exciting missions.
Not a bad sight.
Get up close and personal with the coolest hardware. Talk to the smartest people I can find, and break down incredibly complex topics, because, quite honestly, it's a lot of fun. Besides, with every mission, there's thousands of talented and motivated people working their hardest to ensure mission success. And this truly is the goal of Everyday Astronaut, to cheer on and lift up the people doing the hard work. We're living in exciting times, where the pace of innovation is faster than we've ever seen, where the cost of spaceflight is coming down by orders of magnitude, where the people living today will explore new worlds amongst the stars. The point is, rocket science is awesome, and you don't need to be a rocket scientist to be excited. Everyday Astronaut, bringing space down to Earth for everyday people.
It seems like it might actually be... Okay. All right, we're back. I think I'm going to have to talk quiet because my voice is already completely shot. That's what I get for just like straight up waking up and like yelling, basically. So what I'm going to do here, guys, is I have Kerbal Space Program pulled up. This is, of course, is like part game, part rocket simulator, part space simulator, but mostly just a giant explosion factory. So I'm going to show you how this is totally stock. This is all stock. I do this. I like to play it stock so that you guys can play along if you buy it, not modding it out and being like, well, you have to have this mod, this mod, this mod, this mod. This is totally stock. And in Kerbal, it's a slightly different solar system, but the physics are all the same. So Kerbin's here. This is Kerbal. And this is Duna, which is the equivalent of Mars. And in order to get to Mars, the first thing you have to do is you have to wait. You have to wait quite a bit because you have to wait until you're lined up in the exact correct. You have to line up so that when you raise your orbit around the sun, your orbit intersects with Mars when Mars is there. So we have to wait until like, you know, if Mars is at midnight or at 12 o'clock, it needs to be at about 3 o'clock. It needs to be a 45-degree angle from Mars. And that's when we're at the right place to make our TMI, our trans-Martian injection. So while we're waiting on this, I'm going to answer a few more questions. This is from Sumit says, Godspeed, Bruce Willis. Yeah, he's heading out there to save us from an asteroid. Mika Aloha says, why don't they just use SpaceX recovery ships to catch ULA fairings? I think that could be possible if they really want. Love your work, Tim. That would be well. Don't forget there is actually additional hardware inside SpaceX's fairings that allow them to be caught and reused. There's gas thrusters that orient them, and there's of course the parafoil that they deploy to be able to steer them and steer them precisely towards the ship, and the ship has to do some legwork. So you can't just catch any old fairing, and they're probably made a little stiffer, a little bit differently to survive reentry. Yeah. Good question. That'd be really funny if they started catching other companies' fairings. That would be nuts. This is from Samit. What are the top 5 countries watching you? On YouTube in general. Let me see here. Let's look at the last little bit here. The top 5 countries right now, last 28 days, are the United States. At 35% is all. I'm going to make sure I don't miss this. 35% is from the United States. The United Kingdom, 9.3%. Germany, 4.9%. Canada, 4.7%. And India, 3.4%. So hello to all of our international friends. Again, about the vast majority of you are from outside of the United States, which makes me really happy. I love that there's an international community involved in this. And that's also why I default to metric, because not only is metric much easier in everything, but I default to metric because that's by far the majority of my audience is going to understand and be reading and using metric. And it's just us in the United States and a few other places that are metrically impaired. So yeah, as far as density, I bet you that's what's actually weird is I think we're getting to the point where like 0.1% of the people in the UK watch my content. That's actually really weird to think about because there's 10%. Yeah, I did the math once and the UK is coming up on like properly like high density. So I'm like nervous to come to the UK. I'll have to like have bodyguards and avoid the paparazzi and newspaper. I don't know. No, not that, but it's pretty cool that a relatively small country like the United Kingdom or the population there is, it has that many people watching. That's crazy. Okay. So we're going to look at Perseverance, not Perseverance Dumblander 2 and Dumblander, just regular old Perseverance. I should probably pull this up in the vehicle assembly building so you can see how I built it and what I did. Timothy TM Discord. Tim, you are my density. That's awesome. Okay, so hold on here. Matt Lowndes in YouTube. Hey. Yes, Matt, I will absolutely come drink whiskey with you. Huge fan of Matt. If you guys don't know Matt, I'm going to be dumb here and be doing some Kerbal because I don't know why. Now I feel scared to do Kerbal in Matt's presence because Matt is properly a Kerbal wizard. So if you guys like Kerbal Space Program and Space News, I saw Matt's doing now too. Definitely check out Matt's channel. I'm a huge fan of Matt. We've worked together. Matt helped me try to recover a Saturn V that I accidentally launched the entire Saturn V to the moon instead of just the lander. So that's really cool. Okay, so this is my Perseverance rover or Perseverance launch vehicle. It's Kerbalized, obviously. It's not proportional very well for an Atlas V. It's also way too powerful and way overkill. But what it is, it's still similar. There's going to be 2 main engines. Well, actually, 2 main nozzles, I'll say, because the RD-180 on the Atlas V is a single engine, but with two nozzles. So 2 combustion chambers, 2 nozzles, and a single turbo pump. So technically 1 engine. And then it has 4 solid rocket boosters on this because it was the 5-4-1 configuration. So 5-meter fairing, 4 boosters, a single RL-10 upper stage engine on the Centaur. And then it's got this big old fat fairing that is attached to the first stage, like I said. This is our second stage. And then inside here, this is our cruise stage for the rover. And then inside here, there's a lot of magic that includes kind of a wonky looking sky crane thing and a Curiosity rover. So there's our sky crane and there's our Curiosity rover. So this would be, if I nail this and land on Mars, you guys will be here to witness it, but it'll be a bit of a miracle. So let's give it a try. I'll show you how we do this. Like I said, the biggest thing we had to do first of all is wait, and we had to get ready for to be aligned with Mars. And yeah. All right, hang on. I got to answer one question quick. Okay, so it's a night launch. So let's make it morning because, you know, that's what it was today. So this little tiny bit of time warp does not matter in the grand scheme of heading out to Mars. Like I said, there's actually a 2-month transit window, really, where we can still pretty easily get to Mars. So, and again, this is going to Duna, which is an equivalent to Mars in Kerbal Space Program. The Kerbal Space System is a little bit different. It's a little smaller. So, so this vehicle is a bit overkill. I think I neutered it a little bit, so it's not as crazy, but we'll still have probably way too much. So, yeah, let's do this. You guys ready for this? Should I get some music going? Do you guys want a little bit of music in the background? Let me know. Let me do that anyway, because I think it's more fun to have just a little bit of background music, right? And I'll also get back to answering your guys' questions here. We'll have some cruise stage time and stuff like that. So so stick with me here, and we'll make sure this is a pleasurable experience all around for all of us. Again, we're just having fun here because we just went to Mars, ladies and gentlemen. It is time to celebrate that and get excited. So I'm pulling up some music here for you guys. And we'll make sure that it's not too loud. Maybe we don't have music. Maybe we don't have music. Sometimes it doesn't work. All right, Andrew's going to pull up some music here for us. He can have finer control over the mixing. But here we go, guys. Let's get our butts off to Mars. 3, 2, 1, hip, hip. Solid rocket, or first main engine ignition, and now solid rocket boosters. We're going to immediately roll to align to our azimuth because then I only have to push one key instead of, and we're doing a little bit of a wonkiness there. Probably should have held radial out. So now we're going straight up-ish. And we're going to start our gravity turn just a little bit already to kind of clear the pad like this. We're going to kind of hold about this attitude for a little bit here until we get through the thickest parts of the atmosphere. And also we're making sure that we don't drop these solid rocket motors. These solid rocket motors burn out way too quickly. I definitely probably could have made them so they don't burn, that they don't have as much thrust and burn out later. But this is Kerbal, and they're going to be burning off in 30 seconds, basically 40 seconds. So here we go. We're hitting maximum aerodynamic pressure. And now we're going to go ahead and deploy our boosters. Clean separation, good work. Throttle back up, and we're going to continue to kind of pitch off downrange. I'm going to also watch our apoapsis, our highest point in our orbit here. So I am steering this manually, putting this thing into orbit. I'm not as good as a computer, so if I nail this thing, it'll be a sheer miracle. But I'm going to try and put it into some kind of like 100-ish by 100-ish parking orbit, or 200 by 200. It doesn't really matter, but the lower we are, actually, the more advantage we get out of Earth's gravity well through a Hohmann transfer. So like I said, it's all about, we're going up right now. So if we were to cut off our engines, we just fall. And that's about what the first stage will be doing anyway, is falling. But what we're doing is we're actually just speeding up, raising our altitude and speeding up horizontally at the same time. And we're going to continue to speed up a little more here. And this will put us, put us more and more. And what we're going to do too, once we're kind of clear of the atmosphere, I am throttled down quite a bit because otherwise this thing's just total overkill. And I'll deploy the fairing here in a second because it is actually attached to the first stage once we're high enough for that. But now we are getting our apoapsis up here. That is our highest point of our orbit. I'm looking down on the bottom left-hand part of the screen. You can see our apoapsis is 75. So I'm going to keep pitching over, so we're putting more and more horizontal velocity, which is getting us closer and closer to orbit. We're above 50,000. I could probably deploy the fairing if I want to, but I'm going to wait just a little bit longer. Like I said, this booster is a little bit overkill in Kerbal especially, so we're probably going to be putting this thing almost into orbit with just the booster. Pretty much a single stage to orbit vehicle. Okay, we're at 60,000. I'm gonna straighten out here a little bit, and
Rocket science, a term we all use to describe something incredibly difficult. And rightfully so. I mean, just look at a rocket engine. Stare at it too long, and your brain might melt. Trying to grasp all the concepts involved in rocket science can be incredibly intimidating, and yet rockets were designed and virtually perfected in an era when computers were the size of a room and most calculations were done with paper, pencil, and a slide rule.
Touchdown confirmed.
The sheer brilliance of the people who have figured all this stuff out blows my mind. I, on the other hand, am a prolific college dropout. My name's Tim Dodd, but I became known as the Everyday Astronaut when I randomly bought a Russian spacesuit as a joke, took pictures of myself with it in just about every imaginable situation all around the world in a viral photo series. And in the making of that series, I fell head over heels in love with spaceflight and space exploration. When I started the photo series in 2014, I could barely tell you the difference between a space shuttle and a Saturn V, but my appreciation and curiosity for the subject grew into an obsession. Before you knew it, all I wanted to do was learn more and more, and the more I learned, the more I wanted to share what was making me so excited. But as someone who dropped out of college and has no technical background or degree, I really felt unqualified for the job of explaining rocket science to anyone. But the fact of the matter is, if I can learn this stuff, anyone can. So now, through endless curiosity, an absurd amount of questions, and very little sleep, I obsessively strive to actually grasp all the complexities of rocket science.
Yeah, baby!
But this isn't just some basic surface level information we deal with here. Nope, we dive in deep. We get into all the nitty-gritty details that engineers spend years going over. I'll take you behind the scenes of the most exciting missions.
Not a bad sight.
Get up close and personal with the coolest hardware. Talk to the smartest people I can find, and break down incredibly
All right, guys. Sorry about that. Hopefully we're back. Sorry about that. I don't know what's going on. There's literally mice chewing on my studio, so it's probably something to do with that. I've still got some work to do to make this perfect, but don't worry, you didn't miss any action. I'm working on getting everything all back up and running. I still can't actually see you guys anymore, but let me see if I can get you guys back up. But hopefully you guys see me. We kind of switched systems here, and it should be different. There's something... We found another fault point, but luckily we didn't actually miss any of the real action here. So hopefully you guys are sticking with me here. I appreciate the patience. But all right, we are back. We are back. Okay. Yay. So let's pull this baby up here. Okay, so we got to stage separation. That's the last thing you saw, and now we're gonna slowly throttle up our second stage engine. Whee! Okay, and we're gonna just kind of let this thing run for a little bit here. I'm gonna work on raising our periapsis, our lowest point in the orbit, while trying not to totally raise this too much, because that can be a bad thing. So I'm trying to make it so our lowest point in our orbit, our periapsis, is raised, and you'll see that start to come up basically around the opposite side of the planet. So watch this. You'll see, this is starting to come up here. We're raising the lowest point. It's still negative. Once it's not negative, you'll see it raise up. But if we were to turn off right now, we'd smack into that point basically. So we gotta keep accelerating here. And here we go. It's now above 0, and we can kind of speed it up here a little bit. We're gonna park ourselves in about 120 by 120. That's kind of the target-ish around there. As long as we're in orbit, it doesn't really matter that much. We're just playing Kerbal. We have plenty and plenty and plenty of did we lose signal again? Andrew, are we still good? Weird. Now it's all me. Huh. Maybe it's OBS. We got to get rid of OBS, my friend. That is something Andrew has been talking to me about. We're going to totally switch systems. So we're no longer running on OBS. We're actually going to like professional broadcasting hardware, because I've always been afraid to dabble in that stuff, but I think it's time that we just full-blown go all out, because we're in a new studio space. We can do whatever we want here. We're gonna really put some real stuff on it. So it's time to go nuts. All right, so we are working on circularizing here. If we really want to circularize, what I want to do at this point is coast up to our apoapsis. Which why don't we just do that? We're gonna coast up to our highest point. And then once we're at our highest point, we're going to speed up again, and that will raise our lowest point. We'll try to park at a nice 150 by 150. Yeah, Andrew, go ahead and do that. I kind of got an update. So after this, guys, I will be streaming Starship. There will be Starship static number, or serial number 5 static fire, hopefully. And I'll be trying to stream that this morning. I don't know when I'm going to have time to do Our Ludicrous Future. I'm going to have to tell the guys that Our Ludicrous Future might not happen today. Or for me, at least. Well, at least maybe not on time. Maybe we try to schedule a little bit later. So I'm speeding back up again. I am circularizing my orbit around Kerbin, or which is kind of the Earth analog. And this is going to be good enough. About 150. 150 by 156. Good enough. And now we're going to... Yeah, so here we are. We're in a parking orbit. We'll stay this way. So we did our circularization in 2 burns because I'm not as good as ULA. Surprise, surprise. But now we're going to focus and target Duna. This is the Mars equivalent. And all we have to do, it's quite simple actually. We basically speed up somewhere around here. Hey, where did it go? That was weird. I got to see that maneuver node. There we go. We're going to speed up like this. And somewhere around there. And then we're just going to try and intercept Mars. So we basically are going to raise our orbit until we are orbiting the sun. Once we're orbiting the sun, we'll try and intersect. Oh, barely missed it. So I'm going to push this a little bit here. Something more like this. I don't quite ever know where to go with that. But that looks okay. We're gonna nail it this time. So hopefully those. Oh, we can go a little bit more this way. Nope, we're not gonna quite nail it. I have to push out a little bit more. I never know the best way to do this. Again, where's Matt? Matt Lone, when do you need him? Or Lown. I still never know how to say your name, Matt. It's like Jack Beyer. I never know if it's Beyer or Bayer. Because it's like, how am I supposed to know? What am I, Mr. Know How to Say Things guy? Don't think so. There we go. There we go. That is... And actually, we're going to put our descending node really close to it so we can get really, really, really close. And what I like to do is I like to actually really, really, really refine our... Okay, so the road for Starship is close. We're actually going to switch streams once we're to that point, eventually. And I'm going to work on... We're going to do this mission in a hurry. Okay. And you know they have multiples, right? Okay. Sorry, I'm talking to Andrew. I'm not talking to myself here too much. Talking to our producer, Andrew. Everyone say hi to Andrew. And again, everyone say hi to our awesome mods who help keep this place incredible. So that's going to be good enough. We're going to be flying kind of like I said. Actually, they intentionally do miss Mars with the booster, with the upper stage, and then the crew stage will be the one that actually does all the stuff. So we're going to hit Mars here we have to do our burn in 2 minutes. We're only doing a 4-minute burn, basically because we have too powerful of an engine. Like I said, this whole thing is way too off scale, but there's a lot more margins in it because, you know, I'm not that good. If I was doing like realism overhaul and stuff, it'd be a lot harder. But this is just all stock Kerbal. I'm gonna try pulling up a few of you guys' things as I can. Greg, your girlfriend Dolores should wake up. Thank you, Greg. Let's see here. This is from Yuri. X-33 was about 80% complete, and the launch site was complete at the time of cancellation in 2001. Definitely a childhood favorite of mine. Didn't know Tori worked on it. Yeah, Tori worked on it. Yeah, he had a big part in it. That's definitely something I want to talk to him about. So, Samir says, I read ULA determines the flight path, taking launch days, upper level winds, etc. into consideration. Is it the only launch provider who does that? You know, I think they all have to take the flight, upper level winds and everything into consideration. That's why they have those weather balloons that measure all of that and everything too. But I don't exactly know how that happens. But yeah, ULA, it's rocket science. You got to be taking everything into consideration. This is from me, John. Okay. All right. So this is from me, John. Elon wants a world where people feel inspired. This is how I feel. Can't wait for Starship flight. Also, the last time Neowise was this close to us was before the Bronze Age. That is absolutely wild to think about, actually. All right, we're coming up on our burn here in T minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Mars, here we come, doing our insertion burn. And so we're just pushing this thing out. And what you'll see now is our orbit around Earth, or really Kerbin, is going to raise. So we're basically, our lowest point is down here. And wherever we are opposite is basically going to be where the highest point goes. So now, as we speed up here, we're at our lowest point, and we are increasing our highest point of our orbit by speeding up. So you're always affecting the opposite side of your orbit. So if you slow down here, it'll lower the opposite side of your orbit. If you speed up here, you'll be raising the opposite side of your orbit. You're always basically affecting mostly the opposite side of your orbit, at least when you're prograde and retrograde. So it's, that's how this is how orbital mechanics works. So like I said, we're not even facing, well, we kind of are, we're close to facing Mars. We're pointing a little bit to like the right now if you're looking right at it. So, we're pointing basically this way right now. We're kind of missing the moon, but it really has nothing to do with facing Mars. It's orbital mechanics. So what we're doing is we're raising our orbit so much around Earth that I got to make sure I'm not missing our target either. Raising our orbit here, and you'll see it takes a long time to get like the first little bit, because it just takes a lot of extra velocity to raise our orbit. But once we get out here around the moon, it'll go really, really fast, just like we saw in the telemetry today. And then that'll snap out, and all of a sudden we'll be going out here, and our path will end up heading out to Mars. We're going to do a nice little maneuver node here on the ascending node. That's where the inclinations are a little bit different, because I'm not perfect. Even though in Kerbin here, or in the Kerbal world, a lot of the planets are all on the same plane, so it's really easy to hit planets. In real life, they're all slightly at different angles, different, eccentricities and everything. Like it's actually really hard, different ellipticals. So, Timothy TM wants to know if I have any videos of me using Realism Overhaul and Real Social. Yeah, I used to do it quite a bit, actually. Yeah, so I used to do it quite a bit. Yeah, so guys, we're going to speed through this here. I might not be able to get to all your comments, and I have to just say right now, from the bottom of my heart, thank you to everyone who has donated and who's said hi, who's hung out with me this morning for an awesome day. I'm going to have to switch streams here in a little bit, but I'm just going to throw up some of these guys. Thank you very much from Volker. Like I said, I might not catch you guys, because when we're done with this, we're going to probably pop right on over to, as soon as we have a stream ready, we're going to pop on over to Starship. So, let's see, Tyler, glad you're doing this for us. The topic of missions to the other celestial bodies. What are my thoughts on Dragonfly? I have a video about Dragonfly. At the time, they were deciding between Dragonfly and Caesar for the next big mission, and I was Team Dragonfly, and Fraser Kane from Universe Today, he was arguing why Caesar is awesome, and so I have a video about that. It's a little older. It's almost probably 3 years old now, but definitely check that out. Maybe it's only like 2 years old. Man, time flies. But I love it. Dragonfly is going to be unbelievable. Dragonfly might be one of the coolest missions in our lifetime. Flying a quadcopter around on Titan, that's going to bring some incredible footage back to us. Okay, so you'll see we're right about to break free from Kerbin's gravity. This is our escape trajectory now. And we are officially orbiting the sun. And now our orbit is raising around the sun, which you can see here. So we're no longer on the same orbital path as Kerbin or Earth, and we are working our way out to Mars. So I'll have to shut this thing down basically as soon as we get to that interception with Mars or Duna. So we're getting close. I am going to kind of throttle down so we hit it pretty precisely. Okay, and shut down, and pretty good. Did I hit it? Oh, I missed a little bit, but that's what we can do with these maneuver nodes here. So let's see if I can manually get us a little bit closer here, just a little bit. So in real life, what they would do now, actually, this is probably again kind of what they would do, and they're going to separate here. I'm going to do a quick save in case I mess something up here. But what they're going to do is they're going to deploy now from the booster. So this is still part of the rocket, and now we're going to get my version has a huge aeroshell and a huge kick stage, and it's backwards. I know it's totally wrong, but it made it easier for me while building it, so too bad. So what we're going to do though is we are going to go ahead and deploy from the booster, we're going to do payload separation. So now we are away from the main engine, they call it, even though I call it the second stage engine, normally the upper stage engine. But now we are free from the Centaur upper stage, and we are officially heading to Mars. So like I said, what we're going to do is we're going to get to this. We're going to fast forward here to the ascending node, which is where our orbits are on slightly different angles from each other. So we're going to fine tune that and absolutely nail our trajectory to Mars or Duna. Okay, so let's get out here to that point. Now, a smart person would probably work on that maneuver node now while we're coasting out there. Okay. But, you know, I'm not that smart, so we're just gonna go willy-nilly and just use the like I said, if we go right here, we can end up with a perfect target. We're going like basically right on the equator of Mars, and we'll just absolutely nail it. Add maneuver. Okay, this will be good enough for now. So what I'm going to do now is I'm going to focus back on Duna, which again is pretty much like Mars. And I'm going to work on getting our orbit, first of all, aligned. Is that the wrong way? Or is that the right way? Must have gone the wrong way. Okay, I guess I don't have a good enough... Oh, wait, I'm looking at the wrong thing here. I got to first get us... I have to first get us there. Oh, man, I'm totally missing it now. Let's first get us there. Get a clean... Oh, we actually have to slow down a little bit. We've slightly overshot it by just a tiny bit. All right, there's our closest approach. 47 million. Okay, let's change our... Man, why does it not want me to... I should be able to absolutely nail this, and it's not really letting me. Come on. I don't know what those new numbers are on screen. I've never seen that stuff before. Duna encounter, whatever. We can do this first, and then... oh, there we go. There we go. That's what I need. I need this. Let's nail this. There we go. Now lower it a little bit. Okay, now we're talking. And now we can actually get it so we're literally going to intersect. We're going to aim for the atmosphere. We're going to go right in and get ourselves on a perfect... We might as well do it here. It'll take just a tiny little bit of a burn. Very tiny. Only 20 meters per second. That's ridiculous. But we're going to go ahead and aim for like 25 meters. 25,000 meters, sorry, 25 kilometers. Above the surface, that'll be enough to slow us down. That'll be perfect. If we get this, it'll be very, very, very impressive. So let's go ahead. Oh, I think at this point I need to... Let me think. I think I have a action group because it's backwards. Okay, good thing I thought of that. Sorry, I haven't flown this since I built it for that video like 2 weeks ago, so... All right, I'm going to fire up, get the engine ready. This engine, our orbital maneuvering engine here, our kick stage, only has 50 meters per second, or meters per second of delta V, so it's not a high energy thing. And we're kind of wasting propellant here just by looking at it, basically. So what we're going to do is we're going to fast forward here to this exact maneuver node, start our burn in 30 minutes. We're going to fast forward. And we don't have to be perfect. This will be darn close enough. Okay, here we go. 3, 2, 1. Let's do this burn. And this will get us, hopefully, pretty much right on the money for Duna. This is basically our course maneuver. And this will also make sure that we hit it and our upper stage engine doesn't. Let's see how close we are now. Oh, we are... All right, I'm going to just barely do tiny, oh no. Tiny bits of RCS. Oh, that's too far. Oh, well, we can do another burn here when we get a little bit closer if we need to, because right now everything's super sensitive. Even just doing these little RCS bursts are totally throwing us out of whack, basically. Wait, are we going to oh, no, we're going to hit. Hang on here. Let me double check. We're not first hitting. Okay, yeah. If we miss this, we'll do a cool flyby of the moon, of Duna's moon. Okay, here we go. That's about perfect. Oh, look at that. That's what I'm talking about. Right, pretty much on the money. 24,000 meters above the surface. That will be a perfect reentry. So let's go ahead and coast our way there now. Now this will take a little bit of time, but you'll notice that we're basically kind of catching up. We're technically going faster because we're in a lower orbit than Duna. So we're just going to play catch up and we'll meet up with it when we get there. That's how this transfer works. In real life, this takes, 6 months to 9 months, basically. More like 7 to 9 months. So yeah. Let's answer a few more questions here. This is from William. Morning, Tim. Anything new on Rocket Lab's recent launch failure? No, unfortunately, we still don't have any information about Rocket Lab's. Unfortunately, their first operational launch failure. No new information yet. I'm definitely keeping an ear to the something, whatever you say. Ear to the grindstone? I don't know. Probably not grindstone. I'm definitely, highly tuned in for that. So nothing yet. I can't wait to hear more, though. From Ricardo, hi, Tim. Send hello to Brazil. Hey, Brazil. How's it going? Thank you so much for saying hi, Ricardo. Vincent, this would have been awesome on a Falcon Heavy. I would have loved to see that. Is it too expensive or Falcon Heavy not capable? Remember, again, I kind of mentioned it a few times, but sorry, it was a long stream. Falcon Heavy is completely capable of doing this mission. But at the time when this mission was developed, Falcon Heavy hadn't even flown, right? Falcon Heavy was still just a conceptual vehicle, so it wasn't worth relying on or even betting on the idea of Falcon Heavy being ready yet. And it's still not flight proven enough to really be trusted with a billion-dollar mission to Mars yet. I think it's getting there soon, and maybe after a few more launches, it could be trusted with some higher payloads like that. But it would have been cheaper, but that's not all that matters. Mission success is all that matters. Flo, why do you want me to disable our RCS? Because you don't want me to do a Mars Reconnaissance Orbiter thing? This is from George S. You should see ARCA. They're about to test a brand new rocket. I've covered ARCA a few times in a few different videos. I'm ready to see them do some stuff. They've been working on some stuff, but so far a lot of it's been kind of just smaller test things, and I'm excited. I've wanted to see them do an aerospike, but it's slowly changed from an aerospike to like a steam engine to a bell nozzle back to an aerospike kind of steam engine thing. It's unfortunate to me, like not really hardly it seems like it's getting further and further away from an orbital rocket, but we'll see. I'd like to be proven wrong. That'd be great. This is from Leslie. Thank you so much, Leslie, for the membership. Patrick, to hear the go, no-go poll is really insane and giving me goosebumps every time. Agreed. I love the go, no-go poll. It is something incredible about that. Like, it just makes you happy. I wish that we could hear SpaceX do that. Okay, so we're going to go ahead right now. We're getting ready to do our entry. So I'm going to go ahead and separate from the cruise stage here. I hope this is right. I'm going to do a quick save. And separate from the kick stage, the cruise stage, switch vehicles. Make sure we are in the right vehicle here. All right. So there goes our kick stage. That's going to go ahead and burn up in the Martian atmosphere. And we're going to go ahead and face heat shield first to prepare to enter the Martian atmosphere. Look, we're going to have a cool shot too. We're going to get kind of photobombed here by Duna's moon. So that's pretty cool. All right. So we're going to keep RCS enabled because we're going to be able to still control it and keep it pointing heat shield down. But I'm going to go ahead and fast forward because we're getting close to time to switch streams here already soon. So if I happen to nail this on my first attempt, having not practiced this like at all, I'll be quite pleased. I'll be quite pleased. All right, so here we go. We are descending. I do see an interesting question from Pratik about the Sky Crane, saying there's not much info about it. I have watched my video about Perseverance and Curiosity. I do go into it quite a bit, a decent amount at least. So if you want to know more about Sky Crane, watch that video. I've got you covered. But yeah, it's a really interesting, it's an interesting vehicle, and it's kind of insane that it actually works. All right, here we go. We are entering the atmosphere pretty heavily now. Even though it's thin, when we're going this fast, even 1% atmosphere, when you're going this fast, it still has a big effect. So you'll notice that it is slowing us down. And currently, we're still missing Mars. Well, now we're in Mars, we're in Mars orbit. Wait, what's the difference? Oh, that's the kick stage. So we're slowing down here. Currently, if the atmosphere for some reason stopped working, which it's not going to, we'd still miss doing it. We'd just do a flyby. But we are officially doing an orbit right now and slowing down fast. Look at that. So notice our orbit here. Because we're getting slowed down by the atmosphere, slower and slower and slower, it is lowering our orbit. And it's doing all the work for us. The compression, the actual air resistance is slowing us down enough that we don't have to do any work really. And that's Mars is kind of mean because it's thick enough that you have to consider it, but it's also kind of thin enough to not always be useful. So it's like sort of almost the worst of both worlds, but at least you can aero brake and not have to do a maneuver to actually slow yourself down. So that is good. But if it was just if it had no atmosphere, it might honestly be easier to land on, engineering wise. So here we go. Now we're slowing down even more. We are now suborbital. We're probably going to land pretty close to the edge of this big old cool Grand Canyon looking thing. And now I'm waiting. I'm waiting to go slow enough now to be able to deploy I did put a drogue chute and a main chute on this, even though I don't think it's necessary to have a drogue chute because the atmosphere is so thin and weak. And I'm going to make sure our drogue chute deploys as soon as conceivably possible. Where is it? It's like clipped in here somewhere. I don't know. Maybe we don't even worry about it. So we're still falling. We're mostly horizontal, but I can deploy our drogue chute or try to. Again, the atmosphere is actually so thin I can't even get it out of the shell. So we'll basically be going straight to our main chute almost right away. But no big deal. Minimum pressure. There we go. Minimum pressure. Give us that minimum pressure. And we'll let this one deploy like that. So once we get down low enough, I'm going to go ahead and speed this up because like I said, we might have a Starship static fire to cover any minute, but I wanted to show you guys this because this is still, I know it's, again, the scale and some of the things are not quite correct, but it's a good way to represent actually how all this stuff works. So it will be sitting inside of its aeroshell with the heat shield attached until the chutes are deployed. All right, there goes the drogue chute, working on slowing us down. Again, I'm probably going to have to do a quick save because I might definitely screw up the sky crane maneuver because I've only done it like once. Oh, man. All right, parachutes, do your thing, please. Please do your thing. There we go. There we go. Main chute. Okay, I'm going to do a quick save right here because we don't actually have too much time to deploy the heat shield. We want it to deploy soon so it goes away from us. And then once this thing straightens out and is basically pointing straight up and down, then we'll deploy the sky crane and let the sky crane drop out with the rover dangling from the bottom of the sky crane. Now, there's no ropes in Kerbal, so I'm going to have to do this. We have like a big piston to lower it, but it's good enough, right? We're going to let it straighten out even more because the straighter we are, the better. So then we can have a nice clean drop because I had to stick this in a big old tube. Here's another quick save. I think we're ready to do our drop. Are you guys ready? Are you guys ready? I'm actually kind of nervous, like genuinely kind of nervous. Okay, here we go. Okay, and I have to get ready to throttle. And here we go. We're going to drop it, and it's going to be free fall for a couple seconds. Here we go. 3, 2, 1, drop. There it comes, and let's ignite the engines right now. Okay, we are under propulsive power. I'm going to go ahead and aim a little bit away so we don't accidentally run into the parachutes. These engines are actually way too overpowered for Mars. I should have put smaller ones on. But I did that. So I did that maneuver there just to make sure we cleared the parachute. See, look at that. Because we're actually falling less fast than the parachutes. So, okay, I don't need to go that aggressive. But I wanted to make sure we didn't run into it. So let's go ahead and lower it so we're not just wasting fuel hovering. Yee! Okay, there's our shadow. That'll be a good reference. I better start slowing down a little bit stronger now. A trick to Kerbal is instead of facing retrograde or against your motion of travel, hold it so that it points straight up. And that way, if you accidentally overshoot and go too fast, you don't flip around, because if it's following retrograde or exactly like opposite of your direction of travel, it can be very bad. We're going to be landing on a pretty big slope here. Hopefully our active suspension works well. Okay, let's start. We are 100 meters above the surface. Let's start lowering. I forgot how to do that. I think it's this. There we go. Lower the sky crane, basically. There's the sky crane. And the atmosphere is actually too thin on Mars to have a soft parachute landing with this vehicle that's so heavy. So now the trick to this is as soon as it touches down, just doing a very slow, gentle touchdown. As soon as we get down there, though, and as soon as it touches the ground, I have to cut it and then go full throttle and yeet out of there. We're just gonna yeet out and get out, and then crash the sky crane on purpose so it doesn't interfere with the mission at all. Okay, here we go. Come on. Come on. And touchdown, cut the throttle, and get out of there. All right. Bye-bye, sky crane. And we made it. We are on the surface of Mars/Juno. Where's our sky crane? I want to see it getting out of there. Where is it? I want to say goodbye to sky crane. It was so... Where'd it go? I can't see it. Oh, is that a shadow over there? Yeah, something's moving. I can see its shadow, but I don't see it. Dang it. Bye, sky crane. Thanks for doing so good. But meanwhile, we made it onto the surface. Let's raise our mast. And there you have it, ladies and gentlemen. Perseverance rover, the sibling to Curiosity, made it on Mars. I can't believe I actually did it. Yeah, baby. Let's do a little bit of roving, huh? We're going to go way faster than NASA will ever let it go. NASA, JPL, come on. You guys, you got to take some hints from me. Look at that. Yeah, baby. I'm just going to cruise. We're going to maybe try to do some stunts. Some light stunts. Yeah, I wish it could go this fast. But look at that. It's so cute. I can't believe we actually did it on our first try. I still got it, huh? I still got it. Yeah. Oh, we broke a wheel because I was getting a little too willy-nilly with it. Poor Johnny 5. Stop. Oh, that's kind of fun. It can't do that in real life, but you know what? This is our own version. We can do whatever we want. Uh-oh. This is not looking good. It's stunting a little too hard. Uh-oh. Here it comes. Here it comes. Oh, no. Oh, no. I'm just letting it go while we do comments. All right. This is, thank you so much from Halatour. Thank you so much. Go Perseverance. Epic Space Models, Perseverance, and Curiosity are nuclear powered. Is a shortage of plutonium-238 likely to delay future missions to Mars? So they are working on new legislation and stuff and new permissions to make new plutonium-238 and make new RTGs or radioactive thermal electronic generators or whatever they are. They're working on those permissions to start up manufacturing of those again so we can have more RTGs for new missions. This comes from Chaz Dude. I wish NASA would put a little more into their cameras. We get really cool views from SpaceX on these kinds of things. I wish they would just upgrade, because they have all the great vantage points, but I wish they would at least start giving us 4K on stuff. I hope they do that. I hope they start doing that for SLS. This is from Mike. Tim, pay attention. Not sure what I was not paying attention to, but thank you. Sorry, Mark Gilbert. This is from way back. Sorry, I'm like 2 hours late now. We found out that it was an issue in our telemetry. Had nothing to do with the mission. We had our own telemetry on screen, and we accidentally were following the booster. Not Andrew in my ears does admit that it was his fault for following the booster telemetry and not second stage. It was not Declan Murphy's fault, but I'll apologize on the behalf of all of us here at Everyday Astronaut. Non-space question. What headphone setup do you use for personal listening? Are you an audiophile? I like to think I get a little bit of audiophileness from my dad, who is a genuine audiophile, but I have these, man, I can't even think of my main headphones. They're like MK or MW60s. Is that what they're called? And I really like them. They are, I don't remember the brand. Oh, Master and Dynamic. I actually really like the way they sound, and they're just nice and comfortable. And they're a nice wireless headphone. But yeah, and I have a decent little, like, you know, audio setup at my house. But I kind of haven't had like the full blown audiophile, like, let's get some crazy headphones or anything. And these Audio-Technica, these are, it's the Audio-Technica, the K240 Studios. These are just classic, like, nice flat headphones. They're not really anything too crazy. But yeah, this is from Zagabog. You're doing a better job than the BBC on the stuff. Keep up the good work. Thank you so much, Zagabog. Well, that's what happens when you're talking to someone that just eats, sleeps, and breathes this stuff. You know, this is my life here, basically. So, I would. Oh, I left that up. Bye. So, you know, I frankly would hope that I can do a decent job of covering this stuff, because this is the stuff that really matters to me. This is what I eat, sleep, and breathe. So, I'm gonna try and rapid fire, but I think we got to get ready for the other stuff here. Blake the Drake, thank you so much. Let's see here. Oh, okay. I do have to share you guys something real quick. I have to share this with you guys. I just saw this tweet from John Krause, my friend John Krause. Look at this photograph. Hang on. My Stream Deck is not working, of course. Look at this. Dang, John. Retweet on that, baby. That is so cool. What a gorgeous morning. Beautiful shot. Yeah, make sure you're following John Krause. He does some of the best work. John Krause, and of course, you guys got to be following Cosmic Perspective. Thanking them for their coverage. They were right here on the ITS Causeway. You can kind of see it. Hopefully you see my mouse. It was pretty awesome. So look at this graph. Yeah, they were like right around there. I can't remember if it's this one or this one. I think it's actually the closer bridge here is the ITS Causeway. But great shot, John. We love seeing your work. Thanks for sharing. So let's see here. Like I said, I don't know how much time I have before. Let's see here. I'm seeing where we're at with the with Starship, because I'll probably switch streams here really quickly, and when we do, I have to cut it. Okay. Thank you so much from Senhal. I don't have a feed yet from Rachel and Jean from S Padre, but they're working on it, so they're on their way out. Are they actually fueling up, or what's the status? Okay, so we have experienced TSCO followed by TSSU, Tim Stream Startup. Tim Stream cut off followed by Tim Stream Startup. I like that. We'll work on, we will very, very, very much work on continuing to make a better source here so that we don't have problems. I don't know why like I said, we're probably going to be switching just to full-blown, like, professional grade hardware for live streams and all that stuff. So, okay. I'm working. So I might have to switch streams here pretty quick, but I'm just making sure I get some of you guys up here. So thank you so much. Trans-Martian injection, is that cool or what? Hoping to hear that term more frequently in the future. Yeah, seriously, trans-Martian injection. Like, I want to hear that all the time, because we are going to Mars constantly. That's what I'm talking about. That's awesome. Thanks, Samuel. Brian, fairing separated, and you said it was pointless. Oh, it's now pointless. That's funny. I never thought about that. The idea of playing Life on Mars at T-45 was magnificent. Thank you to whoever suggested it. Still had you hearable, Tim. That is awesome. That is a great idea. I'm not going to do it on my end again for copyright reasons, but great idea. Thank you so much. Let's see. This is Mars by Timmy Trumpet really expresses your hype. That's awesome. Thank you so much. Blame Techie. Thank you for the membership. Let's see here. A company in Denmark built some of the technology on the rover. That's awesome. Thanks for letting me know, Patricia. I did not know that. I love Denmark. I love my European friends. I just like people from all around the world. Everywhere I go to, I end up being like, I love that place because you end up meeting cool people. You see new things. You learn something about something, and it just ends up being awesome. So, Astro 6, what date are they expecting to land the rover on the surface of Mars? Do we know the answer to that? Yes, I believe it's February 18th at 3:30 Eastern. Literally, I'm not joking. I think it's either the 18th or somewhere around there. It's down to an exact minute. They have it all planned out. I was right, Andrew? Oh, off the top of my head. Yes. Oh, real quick. I just realized something. I still have John's thing pulled up on my screen. I realized, look at what pads you can see. I keep telling people, don't discount what's going on at Blue Origin. Because you can see a little bit of a pad there. That's like 40. I think that's going to be 30, or that's 37 where Delta 4 Heavy takes off. This is 41. You can't even see it. 40 around there somewhere. Probably over around here. On the far left is 39A-ish. Look at this complex. This is New Glen's complex. That's its tower and its water tower. It's freaking huge. It is freaking huge. So don't discount it. It's the biggest thing at the Cape, basically, at this point. So that's nuts. All right. I think I lost Andrew. I might have lost you. I'm going to have to switch headphones here. No, I know, but you're on speakerphone. Everyone say hi to Andrew. I'm switching. There we go. Back to my earpiece. Okay, so I'm going to wait until I have a status from Rachel and Jean before I consider switching streams. I remember getting interested in, this is from... let's see. Missions like Commercial Crew in Mars 2020 back then, 5-6 years ago. And now you're here to see it launch and it's on its way to Mars. That is awesome. I'm with you. I remember hearing about Mars 2020 kind of right when I was really getting interested in spaceflight and thinking like, oh, that's so far away. That's the next time we're doing like a big rover in the United States. And here it is. It's on its way. Rehan Jaziel says, hey, Tim, love your videos. Can you explain why the first stage is turning like that? The first stage, that the gravity turn, we talked about the gravity turn, and I showed that in Kerbal Space Program. Hopefully you understood that. But the second stage was rotating a little bit for thermal considerations and thermal constraints. Peyton Baksh, I have a few questions. Why is it facing down? And what are those beams of light that's showing at the end of that is pointing up? They look like lightsabers. So those were the little RCS thrusters, little gas thrusters. And like I said, they're doing that to kind of settle the propellant. They're doing a roll for thermal considerations. There's a lot of just like little things. And it doesn't matter which direction they're pointing once they're in orbit. It's all completely arbitrary, except for pointing to where they need to go when they do their transmartian injection. Let's see here. Speaking of the long-term career of Atlas, here's a scary thought. 1311 success fail rate on SM-75 Atlas during its ICBM career. Yeah, 13 and 11. It was not terribly reliable, just barely over 50% reliable. And now Atlas 5, 100% reliability so far. Thank you so much, Taco. I really appreciate it. Let's see. This is from Yumo. Thank you so much. And Chris Taylor, Curiosity and Perseverance RTGs are both rated at 14 years minimum operation time before power drops below about 100 watts. Yeah, the official mission duration is only 1.5 years Earth years, but as we know by Curiosity and other non-RTG vehicles, even the rovers are putting up there, lasting decades basically. So hopefully Curiosity lasts still a good several years, and we hope for the same thing for Perseverance. Hopefully. I think it'd be cool to have a challenge of like getting to Mars with humans before Curiosity dies. I think that'd be pretty awesome. Watching live from Japan, thank you so much for joining this morning. Salutations from Adelaide, thank you so much. Another Australian, thank you so much, Josh. This comes from Charles. I would love to see one of your in-depth videos on the Canadarm 1 and 2, or Canadarm, yep, and the upcoming Canadarm 3. Yeah, I would probably have to do a good amount of research on how exactly they've changed, and it'd be fun to get some fun videos about our neighbors to the north. All right. Have you ever considered experimenting with amateur rocketry or collabing with other YouTubers like BPS? Yeah, I would. Joe Bernard and I are good friends. I definitely want to cover one of his launches one day when it makes sense to do so, especially if I'm not in the middle of like 20 things at once. But yes, I think that'd be great. I'm a big fan of BPS and Joe Bernard, so you should be too. Thanks for bringing space down to Earth for the Earthlings. How cool is it? How cool would it be if the second stage slingshots the payload to Mars? The second stage pretty much does slingshot the payload to Mars by hitting gravity, by using Earth's gravity basically as a giant slingshot. So absolutely. Thank you so much. This is from Jono Scott. Thank you. There you go. That's pretty cool, K. David. Your name is already in space. That's nuts to think about, isn't it? How does fuel stay at engine in second stage in a vacuum? So that's why they were doing those lightsabers sticking off the top. Those are RCS thrusters. That's to make it so, fuel will just be floating around in the tank once they're in 0G. So they actually are slowly accelerating with those gas thrusters, and that pushes the stage to make it so all the fuel ends up collecting at the bottom of the tank. And then once they're ready to turn the engine on, once the engine's running, then that fuel will continue to stay and remain at the bottom of the tank. So, yeah. Hold on here. Okay. Here's a donation question for you. Did you know they had a concept to launch the space shuttle on top of another larger shuttle? Shuttle launch shuttle. Yes, reminds me of other crazy concepts like Saturn shuttle. I loved that. I thought that made tons of sense. I wish they had done that. Had a fully reusable space shuttle vehicle. It would have taken a really big shuttle to carry the shuttle. It would have been a big investment, but it could have really paid off if they had made a fully reusable shuttle from the get-go that didn't require as much refurbishment. Fear Tech, I'm watching from Australia. It's now over the Indian Ocean to the west of me. Keep up the great work. That's crazy to think about. Now it's on its way to Mars. Thanks for the membership, Robert. I really appreciate it. Zed, hello from Oz. You can check if your name is loaded on board Perseverance at the NASA website. Find mine. Yeah, I think we looked it up. I think I forgot to do this one. I think I did Insight, but not this one because I'm dumb. Jeffrey Hansen, thank you so much for the tip, and thanks for watching. Hopefully they use the metric system this time. No more mix-ups there. Yeah, I think we learned the lesson. Absolutely. Why is altitude lower than apogee? Again, sorry, that was our telemetry's fault. We tried to do something different, and we almost nailed it. Thanks for the coverage. Thank you so much to Tape Farm for saying hi. Thank you, Rob Speed. This comes from Me01. There's not enough material in the Martian poles to have a significant effect if they get nuked. It would not have a very effective way. It would not be a very effective way of terraforming. Yeah. That sounds about right. I feel like it's honestly not a great system, a great way to do it. Is the burn visible from Australia? If it was night, you maybe could have. I don't know exactly where it did as TMI if it was overpopulated areas, but you maybe could have if it was nighttime. If you know what is velocity measured in relation to and how, it starts at 0, so it's in relation to Earth's surface, but then it'd be missing about 460 meters per second. So, I'm pretty sure it's relative to Earth when getting into orbit, but then I think after that, it still just switches to a more generic plane of Earth, but I don't actually know how the orbital mechanics work and what they exactly measure off of. Okay, guys, I've got a live stream set up here for Starship, so I'm actually going to kill this stream, take a tiny little break, and switch over to Starship coverage in a different stream. So if you want to watch me cover Starship Static Fire, you'll have to check out a different link. So stand by. I'm going to go ahead and I'm just going to cut this basically short as I make a transition. But thank you guys so much for tuning in. I'm really, really sorry if I didn't get to you guys' comments. We had some really nice donations like from Karib and stuff like that. So thank you guys so much. Really, really appreciate it. I'll try and catch you. But if you guys want to continue to do what I do, help me continue to do that. Patreon.com/everydayastronaut. And tune in for Starship Static Fire on a different stream. I'll pull that up here any minute. Andrew, if you want to go ahead and get that published to start going live in about 10 minutes, that would be awesome. And we'll see you guys in the other stream in just a second. So thank you guys so much. Congratulations, NASA, ULA, JPL, all the people involved. Can't wait to see this thing land in just a little bit. All right, let's do this. It's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. We'll see you in a second.